Hello, welcome to everyone to the DevOps Track of the SFSCon. Happy to have you here again in presence. Happy to see a lot of persons here at Noitec Park. I won't steal that much time to Eduardo Guerra, researcher of the University of Bolzano. He will have a talk about how agile development impacts on architectures. And so, Eduardo, thank you for being here, and the stage is yours.
Good morning. So I'm going to talk about how to sustain a software architecture, right? And I'm going to talk about some techniques to how can you manage the evolution of a software architecture in an agile project, right? So first of all, I think all of you should know these words, right? That we call non-functional requirements or quality attributes like security, performance, and etc. And when we create our software architecture, we create kind of to sustain these non-functional requirements, right? So we need that performance, we need that security, and we need that other quality attributes, safety, reliability, and based on this, we create our software architecture. So before start, I'm going to tell you a story, not a fairy tale. Actually, it happens in a bank. So yeah, not in a castle, but okay, so this is a true story. In some country, I cannot say the company, but there is this law that the banks need to provide a financial report of 20 years to the clients. And someone in the bank think, okay, I think we should give this in 5 seconds to our clients. Okay, so if you know a little bit of architecture, you know that for having this data ready for giving to all your clients in 5 seconds, you need some storage, some infrastructure to be ready to process all this data and return in 5 seconds. What I ask is, what if, right? So what if it's 5 minutes or 5 hours? Thinking about the architecture, that will make a lot of big difference, right? So maybe if you can process this in hours, maybe you can have a separate storage for more old data, right? You can manage more asynchronous requests, right? And things that maybe in 5 seconds you cannot, right? And then we think, okay, so the client really need that in 5 seconds, maybe a 20-year-old record, maybe he will need for some process or legal purpose. So can we trust our non-functional requirements? I recently did a study, right, in which we identified that many of the non-functional requirements are defined only in production. So when the fire is there, oh, we need performance, oh, we need security, right? Or many of them are changed or even are outdated or has unknown state. So someone defines some performance, the system is implemented, and nobody remembered to check that if that was actually implemented, if nobody complains. So yes, I think that if you base your software architecture in these requirements that can be changed or will be defined only later, right? Maybe you find some change in the middle of the way and it will happen like this, explode in your face, right? But what about Agile? Agile are not supposed to help with these changing requirements. That's not the Agile promise. That's true, but it's mainly true for functional requirements, right? Where you can do automated testing, you can do refactoring, having clean code, and then your code is ready to change. But unfortunately, we know that some architectural features spread through the code, are in the very heart of the platform tools that we use that are not really easy to change through the way, right? So this idea on, oh, let's the architecture emerge, let's start doing, and then we worry about the changes, we handle the changes. For functional requirements might work well, but not so good for the non-functional requirements that might have big impact on the architecture. So, another question, what about flexible architectural solution? Yes, flexible solutions can be good, but if you apply them in the wrong context, can be painful, right? So let's find someone to be guilty about this, right? So recently we have this hype on microservices, which I think it's a great architectural style if used in the right context. So we saw many companies using microservices and then coming back because that was not the right answer for them. So you need flexibility for the things that can add value to you, not because everybody's using or it's flexible to think about later, right? And also you cannot be flexible on every aspect on your architecture. Oh, let's be flexible on security, performance, scalability, and everything, right? If you try that, maybe you can create like the most expensive system already done, right? So maybe trying to be flexible without knowing exactly where, it's also not the answer. So, how? What is the answer? Right now I just show you some problems, and let's see what we are proposing on that, right? So, the idea is to each uncertain requirement or any architecture decision that is unproven or you don't know, instead of calling them requirement, you can call it hypothesis. Because anytime that someone say requirement, nobody question that anymore. Oh, it's a requirement, right? So instead of calling it requirement, let's call hypothesis. Actually, if you pick up the old days of software engineer, you see that requirements were defined as assumptions, right? So the word hypothesis is not, let's say, so new around here. Some examples. So the application needs to answer to 1,000 simultaneous requests. That might be an uncertain requirement, right? Is that right? It's not? I don't know. It is a hypothesis, right? And also I can put that some uncertain decisions, like I think this relational database I choose will be enough to store my system data. I don't know in the next 2 years how my data will grow, right? And I can also consider that a hypothesis, right? And this hypothesis can be both because of future visions and features, because you are searching for innovation and you don't know exactly what is going to be from your product, or maybe because on the technical part you have some unproven solution or some limitation. The fact is, in most cases, in the beginning of the project is not, let's say, you don't have all the answers you will need to know exactly all the requirements. So this is natural for not knowing some stuff, right? So based on this hypothesis, we identify the risk and the impact, in the sense that the impact is how much my system will be affected if I'm wrong, and the risk is how probable is for me to be wrong. And then we can make a plan to handle this hypothesis through our project. So we don't need, the good news is that we don't need to have all the answers in the beginning of the project. We can work with that. So we can choose to reduce the impact or to reduce the risk. And there is a series of techniques you can use for that. For example, we can do a spike, right? A study that we can give us more knowledge. We can like stop a little bit to study a little bit the problem to know, get more information about the technology or a solution. Another thing that you can do This one, to reduce the impact, is work on modularity. So what is the best way I can do to isolate the impact of this in my architecture, right? So working towards reducing the impact. Software analytics, also a way to get information about the solution. So I want to know about the performance. I can measure that. I can do a series of measurements that can help me to make a decision. Flexibility. Yes, you can use flexibility if you know where the flexibility is needed. This one also to reduce the impact. So if I don't know what are exactly my requirements, I can try to be flexible on that specific spot on my system to be able to adapt later. There's a technique also called architectural trigger. This one, you can see, is to monitor when you need to address that issue. Sometimes, for example, the example I gave on the database, is this database enough for my data? Maybe I can define a trigger when my data reach in a certain point or has a certain size, then I will start working on that. So the trigger is like when I need to start worrying about this. Sometimes the trigger never triggers, right? And you don't know, but you are paying attention on that. You can also rely on experiments this way also to understand better the problem, make some studies, A/B tests to gather data, right? So, for instance, you can do some testing with your clients, maybe to understand where your business should go, right? Or maybe also do some experiments to compare two technical solutions, like two storage solutions, two different platforms. The tracer bullet is also a technique that can help you to understand better the problem and can work both on the risk and in the impact. The idea is to create a feature that traverses your architecture, experimenting let's say, one kind of solution. And of course, you can also experiment specific solutions to see if they can validate your hypothesis or not. This way, it's like, I believe this solution can solve, but let's say you need to validate it later. So it's not a solution, it's a solution candidate. So you are aware that you need to evaluate that later, right? Do nothing can be a choice, right? And I always say that it's different for knowing the risks and doing nothing than not knowing what is happening and doing nothing, right? So if you are aware of what is your hypothesis, what are your risks, what are the impacts, and decide not to do nothing, it's completely different for not knowing the problem and doing nothing, which is what happens most of the time, right? So this is an example of, we did this hypothesis mapping in catch-solve, right, where we have, for example, the source, the hypothesis, and the technical plan using these techniques for addressing these issues. And of course, we do that iteratively. Like, so these plans are not fixed. They are always prioritized and executed iteratively. Also, you can identify and modify the hypothesis as soon as you know. So you can, for example, once you do a study or do something else, you can update the impact or the risk. Even, for example, you can do something and figure out that the risk is higher, right? And of course, this is not a silver bullet. This is a way to manage the architectural evolution. So by my experience where we applied it, people can see a little bit ahead and understand the kind of problems they will face in the future, right? So I leave you with this sentence, if you, from my friend Joe Yoder and Brian Foote, if you think good architecture is expensive, try bad architecture, right?
So, thank you, Eduardo. Perfectly in
Thank you.
time, 15 minutes. And now we have 5 minutes till the next speaker will be on stage. If you have questions, please feel free to chat with Eduardo outside having a coffee, and we see us in 5 minutes.
Not 10, but 15.
Perfectly fine.
Okay.
Congratulations.
Thank you.
And let So, welcome back to the DevOps Track. Now we will have Fiete Luer of Emundo, and he will do a talk about machine learning and medical data. And thank you, Fiete, for being here, and the stage is yours.
Thank you. So I'm Peter. I'm research lead at Emundo, a medium-sized software development company. And for the past years, I've been working on machine learning and medicine. And as you can see from the title, I was a little angry when I handed in the talk. So now I'll quickly introduce why I was angry, how I think reproducibility can help being less angry, and how we've tried to do this in a framework called the CGAN framework during this project. So first of all, academic research is shaped by publish or perish. So you either have to publish a lot or you perish. Your fame, your personal career, and your funding often significantly depends on how much you publish, where you publish your work, and how often it gets cited. This also means the work environment is changed by this. You have a lot of time pressure. I've even seen the excuse that a person doesn't have the additional day to curate the code and the data for publication because he has to work on the next project. Very interesting excuse, I think. And it also enables fraud. So if you need to publish more, it's a very easy excuse to say, okay, why not use fraudulent behavior? In machine learning, speed is currently often valued over stability. So you publish fast, and if you try to reproduce any studies, it's very difficult to publish this. This also means there's a publication and a reviewer overload. So as a researcher, I can't even read all of the papers in my own field, let alone walk into other fields, closely related or very different. And the amount of reviewers hasn't grown as fast as the amount of publications. So the reviewers get overwhelmed as well. The amount of reviews per person is increasing, and the time you have for this is getting less. So the reviews get worse. Good work is often rejected. Bad work is often accepted in conferences. And all of this is pretty much a gray area. It's very difficult to say if it's good or bad behavior because many people are trying the best, and it's difficult to say who is not. So what's a basic thing you would want in research? It's reproducibility. And the first stage would be that repeated runs of the same algorithm on the same data set should lead to the same or similar results. That sounds quite logical, but in practice it's already quite difficult because the architectures and the code and everything is not properly described in paper, and the source code is often proprietary. So if you are able to manage to run the code and reproduce the results on one data set for a specific, in a specific environment, the next step is to validate it, so to run it multiple times on the same data set with different test and train data splits. The inability to replicate the data has been a frequent issue in different sciences. So, for example, in psychology, it's been around for decades, and they have started to address it. They have some quality checks, research is getting better and better, but in machine learning, many people are still ignoring this. Not everybody, obviously, but many large conferences don't really have the checks in place to validate the reproducibility, for example. While some values have started to do this, and it's a very important step, it's not sufficient as of now. So it's not prevalent. There is a lot of proprietary data, proprietary source code or models, and there are no adequate quality checks on the source code or the functionality. You don't even know whether the code would run. Many practices in machine learning are non-deterministic, which makes it even more complicated. So it's difficult to reproduce. It's easy to cherry pick, like to fine-tune your own model, that it is doing what it's supposed to do, and to ignore it on the other models. So cherry picking is a frequent issue. And it's getting even more difficult because of the large amount of hyperparameters, parameters which you need to steer the learning process. Since there can be dozens of hyperparameters, many of them can't be mentioned in the paper, and it's easy to also just, not even maliciously, but just forget it in the source code to properly set them to the correct values again. This is even more difficult in medicine because obviously it's very difficult to obtain medical data. Public data sets are usually small or old, and since people have started to realize that data is good for data science, there is a lot of internal data in hospitals, for example, which is difficult to validate as well. If you're talking about reproducibility, people often divide it into the use of data, source code, and the environment. For now, I'll ignore the data part. While it's important in practice, I'll just assume that we have some public data sets which are fixed. The source code and the environment nowadays are closely interrelated. So the source code is steering the environment quite often. In this, we have different methodological things like stratified cross-validation. So if you run your algorithm on different splits, training and test split, on the same data set, there should be a small standard deviation, for example, and it should be valid. Other things are important, like the use of CPU or GPU. GPU is faster, but there are many non-deterministic algorithms making it difficult to reproduce, although there are already deterministic versions which can be used and enabled even if it's slowing down the training. As I've said, the hyperparameters are of high relevance and are required to reproduce once, and other things like randomization parameters are necessary. If you initialize a network, you usually draw some values from a predefined distribution, and to know which values to draw requires the random seed to be set. Okay, so what have we done? This was a joint work between Nimundo and the LMU Munich, co-funded by the Bavarian Research Foundation, focusing on arrhythmia detection using a generative method, generative adversarial networks. I'll not talk about what we are doing methodologically, but about what we are building around it, because we were quite frustrated because we could never reproduce the work other people have published. So we're thinking, how about we use one configuration per experiment for the training as well as for the evaluation. This configuration steers the data, so the data pre-processing and downloading should be deterministic. Everybody should have the same data in the end of the pre-processing. And it steers the code in the environment. So all these reproducibility parameters can be set via a configuration file. The model architectures are defined in this configuration file. And training, saving, loading is also defined in the configuration file. What does it mean, or why is it important? Runs, so experiments, significantly differ depending on these settings. Since they differ so much, it's important to know the settings. In the end, you usually only see the results on a paper. So how about you additionally publish only a configuration file, making it publicly and reproducible? Furthermore, we support various metrics and visualizations focusing on multivariate time series in this case, but we have several layers of abstraction making it easy to, for example, use this for imaging. There are various validity checks possible across data sets, and on the same data sets, due to the abstraction, it's easy to just exchange the data set, which takes like 2 hours, and then run all of the pipeline, and in the evening you'll have all of the visualizations and evaluations. How does it work? First of all, you have 4 commands. You initialize the configuration file based on a model and a data set. You can change this afterwards if you want to, but after the initialization, you just have a YAML file. Here you can still change hyperparameters or other things required for your training process, and this is used as an input for data processing. So based on the config, you retrieve the data either locally from some internal server or in the published version from some public resources, and the data is pre-processed with some heavy lifting operations like related to data cleaning or resampling. After this step, you have a deterministic data set, and you can either publish it or just publish the configuration so that everybody has the same data. Then you have the training step, some lightweight processes on normalization, Fourier transform, data splitting, and so on, and you train your PyTorch model. The model is saved either locally or with some tracking software like weights and biases, and a reference to these models is used as an input for the detection configuration file. So just use a model, start the detection configuration file, or create it, and it's another YAML file, and start the model evaluation. In summary, as I said, I was quite angry when I handed in this talk, so I touched upon various things. I didn't really have the time for some of the things. One takeaway is the current common impact metrics are sort of faulty in the way that they don't really capture enough things. And especially there is no one-fits-it-all solution. So you usually have to look at several different metrics to have a good picture, and they are not enough as of now. The whole environment is also a little difficult to work with. The publication process and the review system are quite flawed. I can also fill like 5 other talks about this, so I started to not touch upon this in this talk at all. For medicine, one important step is to foster the creation of larger open source data sets. So this is a very big endeavor. It's nothing a single person can really do, and it requires a lot of money and legal and so on guidance. But it's one of the most important steps we have to do right now. Some work has started to publish only the test data set, which in itself is quite terrible because you don't know whether part of the test data set was in the training data set, which is, from a methodological point of view, very, very important. But it can be better than nothing. So you at least have some way to validate a little bit, even though it's not enough in the long run. You can also question yourself whether you should evaluate the data or your model on different data sets and whether you should demand it. It's actually quite a common practice, but it's not really enough in its own. So first of all, models are usually problem-specific and don't necessarily generalize very well on different domain or little data. This is, or whether it generalizes well, is a very important insight, but all in all, it's still not really useful if you don't have the code and the configuration file if this is closed source, so you can't check if it's valid or not. So what do we need as steps forward? Public source code, obviously, is a very good first step, but it's not enough. We need to enforce basic requirements for functionality and code quality. Research code is not really the best code when you look at it. And there's a way too big overhead to check for complicated matters, like was training data and test data in this current review process. You can't expect it from reviewers. So you have to reduce the amount of work you give to the reviewers, for example, by building pipelines for common scenarios. All of the scenarios differ a lot between each other, so it's only possible to sort of standardize it, but this can be enough for various areas of research. If the review is quick, because you only have to look at a new data set or a new model added to this pipeline, you can also easily check the configuration file if some of the settings are weird and questionable. There are various easy-to-use technical means which can be improved still, like the use of non-deterministic algorithm in some cases, and I think especially in research they play an even bigger role. If possible, it would be the best if you have a completely reproducible outcome, so you have a Docker container with all the relevant code, the packaged version and the data, which you just publish, and everybody can run it. You don't have to ask yourself, am I doing something wrong, or is the code not running at all? And another takeaway, which was quite important for me, is avoid bitterness, because I was quite angry. It's sometimes really difficult to remember that everybody is trying their best, or should be trying the best. You need to be open to corrections, and mistakes are human. This is a two-way road. Thanks. Don't hesitate to contact me. The code is public on GitHub, and more information can be found on the blog post.
Thank you, Peter, for your nice presentation. There is still 1 minute time. Someone has a question. Just 1 second, the microphone is arriving.
Thanks, very interesting. Now a question. You are talking about the publication of a health data set, which has very heavy privacy implications. So what are your plans about the publication of those? Do you plan to publish anonymized data set? And if anonymized, they will differ quite a lot from the original. So what is at the moment the current thinking about that? Thanks.
I think this really depends on the area you're working in healthcare as well. So is it about genomics data, which is way more dangerous than, for example, ECG data? And each field has to find their own solution. I don't think I'm the person who's able to say how it should be done, but it's a thing which needs to be addressed more in depth by governments, for example, and where we need to build better ways to, first of all, capture the data, but also to regulate it in a way.
So, thank you. The time is over. If you have other questions, feel free to do it in front of a coffee, and see you in 5 minutes here for the next speaker. So, welcome back to the DevOps track of the SFSCon. Now I'm going to introduce you Justina Ivanova of University of Bolzano, PhD student, that will present us a project about climbing and software. So, Justina, the stage is yours. Thank you for being here.
Thank you very much. Hello, everybody. My name is Justina Ivanova. I'm currently independent researcher, and I present talk connected with recommender system for outdoor sport climbing. This is my presentation. First, I will introduce you with the topic of sport climbing. What is it? Then I will outline research goals which we found in this domain. Then I will discuss existing systems which in other sports related similar to climbing. Then I will discuss research problems and questions which we found. And then I will present the recommender system itself and introduce future plans. So what is sport climbing? Sport climbing is a challenging sport and it's very competitive sport. Here I'm using my personal pictures, which we have taken with my friend in 2014 when we first time came to Italy for climbing. We were traveling, we were experiencing local culture, and we climbed different beautiful mountains. Here you can see also on the right-hand side the competition, which is held in Arco. Every year, it gathers all the top performance climbers in Arco Stadium, and people compete, they climb. So, climbers would like to travel the world, and they would like to visit beautiful places, and they would like to climb beautiful mountains. And we came up with this research problem. There is a lack of decision support tools supporting climbers in their activities, such as training, climbing, finding suitable climbing routes, and suitable climbing places. And for this purpose, we found two goals which we would like to address. First one is to enable climbers' activity detection for recommender system, and second is to propose personalized decision support systems for climbers. Then we started to look into other domains and into existing systems which have been developed for sport climbing. And in 2009, you can see that there was a system developed for climbers who would like to climb different climbing routes. This is the example of interface of such system, but the limitation of the system here is that climbers should manually insert their feedback about climbing routes they tried, they liked, and they are not profiled automatically. Then we started to look into hiking domain. Here I show two systems, one on the left-hand side, mobile app for hikers who would like to hike. And here hikers insert their preferences or characteristics of hiking paths and receive recommendations on the mobile application. On the right-hand side, I show the web interface, a web-based interface for hikers to visit hiking places. And hikers are profiled manually via different type of questionnaires. The limitation here is, again, that hikers should insert their preferences manually and they are not profiled automatically. Then we looked into running. Here, the runners are profiled automatically based on the sensor data. This sensor data is coming from wrist-worn sensors, which are used during the training for marathon. And based on the statistics, based on data, profile of runners are built automatically. Based on this automatical profile, we can recommend training plans for runners. The limitation of the system is that people who do not use sensors will not receive the recommendations. And we decided to address all the limitations and to develop content-based climbing recommender system for climbers. Here we use feedback of climbers given as a logbook information. Basically, climbers use a website and they provide their feedback in terms of like, dislike, comments, and grades for climbing routes they climbed and for climbing places they visited. And we use this logbook data in order to profile climbers and to give them recommendations. Firstly, we give the recommendations in the web interface for climbing cracks, and climbing cracks are places which have approximately 10, 15, could be 100 climbing routes. And then we provide recommendations for climbing routes within the crack. So it's two-stage recommender system. Recommendations are given for three purposes: for motivational reason, for favorite moves, and for training. So this system was then developed as a prototype. For this purpose, we use approximately 130 climbing cracks in Arco region, and we used approximately 700 climbers and their feedback, and developed a climbing recommender system and evaluated this system with first 35 participants who are outdoor sport climbers who at least climbed 1 year outdoor. And we evaluated according to system usability score, which shows whether the system is perceived as acceptable or not among the real users. The first evaluation was done with 35 participants, and the SUS score was approximately 72, which is, according to this SUS, is good, is perceived as a good system. And then we improved the system because there were bugs, and performed the second round of evaluation with 13 participants. Improved system achieved a SUS score of 90, which is excellent score, which means that users are actually interested in such kind of recommendation. Then we started to look into another problem, which is connected with outdoor sport climbing. Unfortunately, in outdoor sport climbing, there are many uncertainties. Rocks are falling, cracks are restricted with the access, and weather sometimes destroyed the land. And in Italy, this problem is specifically important because here the landowners who actually have lands where cracks are located, they sometimes close access to the cracks. It happens because there is a law: if the climber visited the land where the crack is located and have some injuries, then the landowner is responsible for this injury, which is very strange law. And that's why landowners would like to protect themselves. They close access. We tried to model this environmental uncertainty. We called this problem is outdoor uncertainty. And we decided to model as climbers' visits prediction model. Here the assumption is that if we predict how climbers visited crack or cracks, then we can actually understand whether crack lost access or not. So for this purpose, we web scraped climbing cracks features, and we understand first how climbers visit cracks based on those features. So is there any reason why climbers visit crack? For instance, here on the x-axis, I show features of the cracks, and on the y-axis, I show different users and their visits, correlation with features. And for instance, user number 2 has the highest correlation of visits with family-friendly feature, which means that this user is interested to visit crack family-friendly. So probably this user has kids, and for this user, it's more interesting to have recommendations for family-friendly cracks. Then we applied different models to predict visits of climbers based on the features of the cracks and based on their previous visits. Those models are basically solving a linear regression problem, and we applied polynomial regression models and linear regression model. And the baseline was the most popular model, which recommends based on the most popular cracks. We can see that this problem can be actually solved with polynomial regression of 4 degrees, and the results are significantly better. Here we measure the top K recommended items, so we measure the quality of recommendations. That means that recommendations can be given according to the visits predicted by the features of the climbing crack. And we, after that, used the system which we developed for the new prototype. Here, we have different features and preferences of the user defined as the correlation for each feature of the crack. And then we predict for each user the possible visits based on these correlations and recommend cracks based on the visits of this user. And if there is a new user who would like to receive recommendations, then we measure the most similar user who actually recorded ascents in our database. And in that way, we recommend only climbing cracks which were visited by other people and not lost access before. This is what we done after we took 85 climbers and asked them to evaluate 3 different systems. One is 27 cracks, which is the baseline, which is existing in this domain. And then we took 2 systems. One is content-based climbing recommender, which was developed by us, and visit and climb system, which addressing this uncertainty, outdoor uncertainty. We can see that our systems in every metrics, on x-axis I show every metric of recommender system, and we can see that our systems, 2 of our systems, outperforms the baseline, and moreover, the visit and climb outperforms significantly in such metrics as information sufficiency, transparency, overall satisfaction, and use intention. Then we evaluated according to the framework where we try to analyze why our system is perceived better. Here we compared our system, which is visit and climb, with baseline 27cracks.com. And we can see that, for instance, system visit and climb gives higher level of transparency, which leads to higher level of use intention. And the system gives a higher level of recommendation accuracy, which gives higher level of perceived usefulness, overall satisfaction, and use intention. So this work is done for now. Then we also looked into image-based recommender system where the assumption is that climbers choose climbing cracks based on images, and if climber chooses one image, we can recommend based on the similarity of images of other cracks, similar cracks. So on the left-hand side, I show the web interface, how user can choose the climbing crack. On the right-hand side, I show the top 5 recommended cracks based on the similarity of climbing cracks. Free software tools which we used are Flask, Python, PyCharm, which is free version, Jupyter, Leaflet, Seaborn, Scikit-learn, SurveyMonkey, Bootstrap, and JavaScript. And what are the next future steps? Future steps are connected with the training recommendations. Right now, there are companies who are working for sport climbing training recommendations, but they do not provide intelligent solution. They just simply generate solution on the go. So we would like to improve this algorithm. And that's it. Thank you very much for your attention. Is there any question? I'm happy to hear.
So thank you, Justina, for the presentation.
Thank
and
you.
Now it's your turn. We have still 1 minute for a question, so someone wants to ask something. Otherwise, I do have a question.
Okay.
You said that for climbers, actually, you don't use sensor data. Are you planning to integrate sensor data in those kind of use case? And if yes, which one?
Okay, thank you very much for this question. Currently, I'm looking into wrist-worn sensors, which are provided by Kryptonite company. And those sensors provide statistics about how many moves climbers did and whether one hand is more moving than another hand. And they also measure the frequency of climbing routes they climb. So yes, to answer the question, I'm planning to implement sport climbing training recommendations based on the wrist-worn sensors.
Thank you.
Thank you, Stefano.
So, thank you, Justina, another time for this nice presentation. We see us in 5 minutes for the next talk. And if you want to discuss this topic, you will find outside Justina.
Thank you.
See you. Thank you. So, welcome back for the last talk of this morning of the DevOps Track. Now it will be the turn of Gabriele Sancaride of EcoSteer, and the topic will be blockchain for data economy. So, Gabriele, thank you for being here, and the stage is yours.
Thank you. So, hello everyone. My name is Gabriele, and I'm a product developer at EcoSteer. And today I would like to talk about our patented technology called Data Visibility Control Overlay and how it uses blockchain smart contracts and multicast end-to-end encryption to enable privacy-centric multicast scenarios such as V2X. So in so doing, it also enables GDPR-compliant data exchanges. So a lot of big words. I'm going to try to explain this a little better in the upcoming slides. So as you know, current economy and society are quickly moving towards a hyper-connected, digitalized world. New technologies and technological trends that emerge, such as 5G, digital twins, artificial intelligence, vehicle-to-everything, are all based on the availability of real-time data. So all of these technologies, by default, assume a flourishing data economy where data exchange is immediate and free-flowing. However, current data sharing infrastructures are centralized and fail to provide a reliable, ethical, and GDPR-compliant mechanism to share real-time data. So, first of all, they continue to marginalize individuals who continue to have no role in this new data economy. And second of all, data sharing infrastructures themselves suffer from huge costs and liabilities associated with GDPR compliance. So this is where EcoSteer's Data Visibility Control Overlay comes in. Based on our patented multicast end-to-end encryption scheme and blockchain smart contracts, it assigns data access control at its point of origin, any IoT device. So when DVCO is installed on any edge device, it makes it so that data streams flow through the data sharing platform, so broker encrypted, and can only be decrypted at the point of their usage after data owner's explicit consent. This consent is given and revoked via a smart contract. So what I would like to do today is tell you more about how the process of data visibility control overlay works and how multicast end-to-end encryption and blockchain smart contracts establish this decentralized data access control. So before doing that, I would like to do two things. First, I would like to outline some terms that I'm going to be using in my speech or already used in my speech. And second of all, I'm going to give you a very quick introduction to our software architecture. And hopefully these two things are going to help you understand what follows a little better. So let's start with the terms. So for us, a data owner is any individual or legal entity who's the rightful owner of a specific set of data streams. So for instance, a car driver. A data user is any stakeholder who is interested in receiving those data streams, which could be, for instance, an insurance company. A broker is a technical component, so a pub/sub broker which uses protocols such as MQTT, NATS, or Kafka, and it is a component responsible for data sharing and inherently privacy and security. A DVCO-enabled publisher is a data streams generating device with DVCO capabilities, so meaning that our DVCO stack has been deployed on the device. For instance, a car's telematic box. And a DVCO-enabled subscriber is a destination target of data streams, which could be, for instance, an application of the insurance company. So going on to the DVCO architecture, it is built from two building blocks, so DVCO stack on the right and backend middleware on the left. The division between the two outlines the decoupling between the interactions that happen between users from the interactions that happen between the physical devices themselves. So DVCO stack is responsible for multicast end-to-end encryption. So what this means is that the publisher generates a new cryptographic tool with a configurable frequency. The subscriber needs to acquire this tool periodically. The communication between the two is managed by the DVCO proxy, so a key management component sitting in a cloud, which also communicates with the blockchain on behalf of the publisher and the subscriber. So here you can see just one proxy. In reality, to even increase decentralization even further, there can be multiple proxies that are chosen randomly by the publisher. And here we're talking about the interaction between the physical devices themselves. On the left, we have backend middleware, which facilitates the development of the front-end applications on top of our backend middleware to allow data users to interact with the blockchain smart contracts. So for instance, a data owner can perform actions such as a creation of a product, so product meaning a data stream or a set of data streams. From data user side, this could be subscribing to a data stream of interest or unsubscribing. So the blockchain is a unique point of contact between these two building blocks, and it enables a one-to-one relationship between each data owner and all the interested data users, allowing in such a way for data demand and data offer to meet in a decentralized way. So going a little bit more into detail on our smart contract, again, as I've mentioned, on the data owner side, it enables interactions such as grant, revoke, and subscribe, unsubscribe on data user side, among others. On the proxy side, it allows to set and get the new cryptographic tools on behalf of the publisher and subscriber. So our architecture is highly modular and highly decoupled, meaning that we can actually integrate ourselves with any blockchain with smart contract capabilities. And so far, we have developed providers for Ethereum, Algorand, and Quadrants. Great, so finally we have arrived to the DVCO process itself. So to facilitate the understanding a little bit better, I'm gonna be using a vehicle to everything scenario. So let's imagine that I'm a data owner who has a car. My car has a telematic box which generates data about my speed, acceleration, etc., etc. My telematic box also has DVCO capabilities, meaning that our software has been deployed on a telematic box with a simple over-the-air upgrade. This means that any data stream generated by the telematic box is encrypted at the point of generation before it is sent to the broker. My car also has an onboard control panel, which has an application, a front-end application developed on top of our backend middleware. This means that as a data owner, I have a possibility to unilaterally grant and revoke access to my data, so data generated by my telematic box, with one click of a button and any time to any interested subscriber. So what happens from a technical perspective? Well, my telematic box with DVCO capabilities generates a new cryptographic tool with a configurable frequency. It sends this new tool to DVCO proxy, which instead forwards information necessary to acquire this new tool to the smart contract. This cryptographic tool is then used to encrypt the data that is flowing from my telematic box to the broker. On the other side, we have a subscriber, so an application of one of the third parties that expressed interest in my data stream. From a technical point of view, this means that subscriber application has subscribed to a broker topic associated with my data, and in fact starts to receive my data immediately. This data, however, is encrypted because the subscriber for now does not have the right cryptographic tools to decrypt the data. So let's say that I have decided to change my mind and grant visibility over my data to this particular subscriber. I go to my onboard panel in my car, find, let's say, an insurance X, and click the button Grant. This, in turn, changes the status in the smart contract. So the next time the subscriber asks for a new cryptographic tool from the proxy checks the status of the smart contract, and this time the smart contract indicates that the subscriber has indeed been granted visibility over my data. The proxy then sends the right cryptographic tools, and the subscriber is able to decrypt the incoming data. So if you imagine that there is not one, but 100 or 1,000 interested subscribers on the right, you can see how managing data access control in a decentralized and granular way can have enormous benefits. So an increasing number of subscribers on the right has absolutely no effect on the device publishing the data, so my telematic box. So what are the benefits of our data visibility control overlay, especially in V2X scenario? Well, first of all, DVCO API allows data owners to have unilateral control over their data visibility in connection to any third party. Second of all, the broker, so data movement platform, can be turned into a neutral intermediary as envisioned by the EU GDPR, meaning that they can remove any costs and liabilities associated with the GDPR compliance, but possibly creating an opportunity to earn profits from platform management, for instance. From the data user side, data user is able to establish a one-to-one disintermediated relationship with each data owner, so driver, meaning having access to nominal and granular data streams of enormous value. Not only, our technology is also technically ready to handle hyper-connected future scenarios, of which I spoke in the beginning. So first of all, it displays software characteristics such as high availability and horizontal scalability. Second of all, it leverages existing protocols for increased pervasiveness. And finally, due to its modular architecture, it's able to integrate itself with new and future technologies with ease. So, as you can see, data visibility control overlay truly has the capacity to become a future-ready means to control data visibility in highly transactional IoT scenarios. So based on our multicast end-to-end encryption scheme and blockchain smart contracts, it assigns data access control at its point of origin, any connected IoT device. This means that data users are able to ask for data visibility directly to data owners, thus establishing with them a one-to-one disintermediated relationship, and in so doing, reinforcing GDPR. This, in turn, provides a key to a trustless and mediated ecosystem of data exchange where all the players are rewarded for participating. Thank you very much.
Thank you, Gabriele, for this nice presentation.
Thank you.
We have still a little bit more than 1 minute for a question. There.
What framework have you used for the blockchain, and how do you make use of EVM? And how do you make use of Ethereum virtual machine?
So we host our smart contract on Ethereum. That's the only reason. So basically, it's just managing data visibility, so having possibility to grant and revoke access to data visibility. It has nothing to do with data streams themselves, let's say, because sometimes we get questions whether data is hosted on the blockchain. No, it's just...
You have your own proprietary blockchain?
No, we don't have our own proprietary blockchain. We're using smart contracts now in Ethereum, Algorand, and Quadrant. In the future, we want to integrate ourselves directly with NFTs to mitigate, let's say, scalability a little, increase the scalability.
One moment, please. Otherwise, the people online won't hear the question. Thank you.
No, I don't know very much on blockchain, so maybe this is a stupid question, but which is the advantage of using blockchain for doing this job, this task? I mean, you can do these things also maybe without using blockchain.
Yeah, you can definitely do this also with a database, for instance, but database implies centralization by default. So blockchain for us is extremely important because it provides decentralization. So let's say it allows really to create this one-to-one relationship between you as a data owner and everyone who's interested in your data without the mediation of any central party.
Thank you.
Okay.
Thank you.
So the time is over. Thank you for your nice presentation. So the DevOps track in this room for this morning, it's finished. We see us at 2 p.m. here for the next speaker, which will talk about Oniro. See you.
and gentlemen, welcome back to our DevOps session of the afternoon. A lot of motivated speakers and interesting presentations are waiting for you. The first speaker is Stefan Schmidt. I asked to come to the stage. He's a passionate software developer, did a lot of Linux projects, and he is, after many years of freelancer, working in the Huawei Open Source Technology Centers. And he's going to present the release 2 of the Oniro project. Please.
Thank you. So if you look at the picture, you can see that's not me. So that's my boss. He's not able to come here. So if you're looking for any charming, charismatic Italian speaker, sorry to tell you, it's not coming, it's me. Anyway, so we had Oniro. We had it last year already. Last year we have been here presenting about what Oniro is, what we are doing, and this time we want to present about the release that's imminent right now. So right now we're actually working on the last merge request to get that done, and hopefully within the next few weeks we are calling it a full release 2.0. So I want to talk a little bit about what we've been doing this year, the full year. So Oniro is designed to be a full production grade open source. So it's not only meant to like toy around with, but really meant for like companies to build on top. So it's an Eclipse Foundation project. We have like 9 members right now. We launched at EclipseCon 2021. That's the official launch. We worked on that before on the project, but then we launched it within the Eclipse Foundation. It's for devices big and small, the OS here, so it's not a new OS or anything, so that's something people often confuse. So we're still using Linux, we're using Zephyr, so the kernels are already something that exists. We only take them and make them work for us in a better scale. We have opinionated defaults. That means we have like ideas how we want to run the system, how we want to build the platform. This is something that we provide that can be changed if you're a device manufacturer or something. You can change these things, but that's something we want to bring up, and not only a collection of libraries that everybody can put together. We build a full system basically. And for that, we have like continuous integration, deployment, validation, compliance, all the other things that are running all the time to make sure that we build something and test it all the time that is really workable. Yeah, we have SBOM, we have VNV reports, all kind of artifacts. I have to be a bit quick here because my boss put in a lot of slides. And obviously, we also have like bug and CVE policies and service level agreements for maintenance and long-term maintenance. So we are market-driven. That means when we started, we looked at the market, we talked to partners, we gathered the requirements from them, and then from there distilled what we thought was like a good baseline to start off and go ahead and build a platform for people to work on. The 20-80 rule, so we try to deliver like 80% of the stuff, and then the rest you can do like 20% you can do on your own, but it will cost you 80% of the time. So we still at least want to give you something you build on top of, but yeah. So again, integration, opinionated defaults, and documenting, compliance, all these things would be there. You can start with, and then do your own application or integration or building for a specific hardware or whatever you want to do. And we also have the infrastructure, so we're running on GitLab. We're having all the CI pipelines set up there, making sure that everything runs smoothly. Also having a compliance toolchain that is also running in the background, also tied up with our CI and so on. So let's go down the rabbit hole here for 2.0. What did we do the last year? So Bitbake, this is our tool to knit all the things together. That is the heart of the Yocto project, basically. So Yocto has this approach of different layers. I come to that later. So it basically takes all the pieces and integration parts, but also like code and information to get it all together, build it, and then in the end there comes a final image you can put on your device and then run with it. It's a broad collection of libraries, it's Linux and so on. There's also the Linaro Ledge project, which also had a lot of information, and they are providing that in terms of Yocto layers that we can integrate and we are using as well. For hardware scalability, and in general, as I mentioned, there's the layered architecture, and you can see here how that looks like. So if you have a checkout of the Oniro build and want to get started, you can see all these different folders here. And these are for the main build system, like Bitbake. They're also like the Oniro receipts, so all the things we are adding on top, and like how we modifying the existing libraries with our default settings and making sure that everything runs smoothly together. But in general, the big amount of code we are using here is from other open source platforms. So we're really doing a lot of integration work here. So it's coming from the Open Embedded project, which is part of the Yocto project, basically. Then there's the Linux kernel. On the smaller side, there's the Zephyr kernel, and so on. We have the hardware support for all of these. We have documentation, IP policy, and again, Zephyr FreeRTOS is something we have like experimental support for. That's another RTOS system, but it's not really developed much. It really depends on a partner or some interested party coming in and want to join and help. We're also working on an OTA delivery system, so that's something that is a bit more unique, and that's something we develop within on Nero, how we want to handle that for like the bigger devices, for the smaller devices, and so on. And OpenHarmony, that's another component we are putting in there, but I have another slide deck on that. So devices big and small, the way we are doing that, the way we are exposing and designing that in Nero is with flavors. So when you set up your workspace, you give a flavor for either Linux or Zephyr at the moment, or you can go with FreeRTOS or LightOS or something, and that would do all the setup for you to have the correct toolchain, to have like the correct settings. Then you can select the machine depending on what you want to do, what you want to support. It could be a virtual machine like a QMO, or it could be a hardware device or something like that. So we have some supported, but due to the Yocto layers and so on, it's very easy to bring in other boards and your own BSPs and your own hardware support, basically. So we have support for Linux 5.10 with Cortex-A devices, Intel RISC-V. We have Zephyr 3.1. Again, it's a Linux Foundation project. That's mostly for the smaller devices, Cortex-M-based, MCU, microcontroller-based systems. Again, FreeRTOS experimental, I mentioned that. And LightOS is something that comes from the Huawei side. That's another RTOS that's developed in Huawei. It's really popular in China. So that's something we also have like experimental support within the Meta OpenHarmony addition to Oniro. Basically, that's what I brought up here. So we have different hardware support already. We have also QMO support for virtual development, which is really nice and for just your normal development on a laptop or something like that. Raspberry Pi, very, very popular device. We have the support Raspberry Pi 4 in 64-bit mode, but also other Pis could be interesting for others to play around with. And then Zephyr, that's a board from Arduino we are using there. Yeah. Okay, so what else did we do? We don't only do hardware support and integration, but we also do new stuff. And so we have interoperability, connectivity. So there's the project Meta, which was it's a language for the IoT devices, which was released, I think they released it in September, October timeframe, 1.0. There's a spec and an SDK for that. We integrated that, so we have a possibility to use that with other devices out there. We have OpenThread, which is a low power communication protocol, a wireless communication protocol for a mesh network where you can really run small devices on a coin cell battery for a year, for example. So if you have a sensor or something, you still have wireless communication back to bigger devices, which is quite interesting. OpenHarmony, I mentioned that. It's a full stack of software that can run either on your mobile or an IoT device. It's developed by Huawei, also again popular on the Chinese market. So that's something we have as an add-on. So we can bring that in as a different layer, and you can build it based on the Onio platform. Podman, that's something we're using for containers. You basically can run your Docker containers. Podman is just a bit more secure here, how you can run rootless and stuff like that. But so we have a story to deploy your applications and everything based on Oniro. You can do that as a container deployment if you want. Modbus for industrial IoT, it's just another supported connectivity we're having. And LVGL Flutter, that is our idea so far for UI and UX, what you can do. LVGL is something natively, you can run it on Zephyr as well as Linux, and Flutter is, that's more like something you can also run on Android devices and so on. So on SysOTA, that's the OTA platform we are developing to really bring over-the-air updates to all the devices you're having. So OpenHarmony, this is packaged in a way that it's another layer. So I mentioned that before in Yocto, you have all these different layers you can put together. It's a really nice way of being modular and really targeting the ideas and use case you're having. And if you want to support OpenHarmony, you would add the additional layer here, and then you get support for that. So we're doing an IP analysis on all the codes going on. That's ongoing right now. We're hoping to finish that towards the end of the year. And once you include that into your layers, then you can be OpenHarmony compatible. So that might be interesting for people that want to ship their devices to be OpenHarmony compatible. You can do that with running this add-on. And then you have support for extra things, cameras and screen incorporation. and a few other things that that OpenHarmony brings into the play here. So Eddie, I gave a talk about that this morning at 11:20, so I will really brief on that. It's working. It's an idea to have like a distributed device agency, so you have an understanding. You have like a unified pool of resources in your network, in the distributed network, and then they can be used together to make like make intelligent decisions, decision-based process. That's a research project we are doing with the with the Politecnico di Milano. And that's ongoing. So we have like part of that is already implemented on Linux and Zephyr. We have the communication and the virtualization layers done so far. It's based on CoAP, which is a constrained application protocol for a resource directory. And we have a demo for that. If you look at the Eclipse booth out there, we have a demo that is showing a door lock and a smart touchscreen that's actually using Eddie as a background for the communication part. Okay, so we have, it's a lot of slides, I told you. For the companies that want to use this project, it's also quite interested in not only have the technology, but also all the stuff around it. So if you're a compliance envelope, you have verification, validation, and so on. This is something we want to keep ongoing in a continuous manner. So we have like the OpenChain and OpenSSF. We're working with them, trying to implement all the guidelines they are giving and being compliant with that. We have a continuous license compatibility, so we have a dashboard for that to see what kind of new code comes in, what license it has, like it needs to be audited, then we can generate an SBOM out of that. And then we have Lava, which is a testing framework coming from the Linaro side. That means that every build we are doing, every merge request that comes in, it gets built and then actually executed on real hardware in some test lab, and we make sure that everything, at least the smoke testing, is working. So that's quite a lot of things going on. One of these test labs is actually right now being prepared here in Neutech Park. So Neutech Park is a partner of the project, so that's like one of the things they are doing. So our IP team rocks. So not only have like a rock star in there, there we go, but we also have like, they're doing a lot of work. So they have like, in the release, we have like 4 million source files audited within 9 months. So they really have to look at all these things, making sure that the license is fine, that they don't have like any problems with that. So going on that, we have like a really big coverage already, 89%. We have like around 100 issues that have been identified in open source projects or in different components, and then reported them back to upstream. We told them, okay, there's something wrong, your license looks odd, or you have like binary files in there, you have a proprietary font or something like that. So we reported it back, worked with them to get it fixed, and then backported in our. So that's like part of our duty to make sure that we also bring it back to the open source projects. We have a lot of things, so we're using scan code and pathology improvements to like have our pipeline running well. That's something we are working on as well. And there's more work ongoing for deeper integration. So, okay. Again, verification and validation results integrate into the process. We want to have a test plan 100%. That's always a goal. I know we have like, right now we are covering like 80% of our release epics. That's the requirements we are having, and having an 85% pass rate. The Lava loads, as I said, they're running and they do the automated testing. And we have a bug triage process and really trying to like get all the bug fixed and have like a SLA for like all the maintenance and long-term support and so on. Checkbox integration. Okay, so system OTA, that's our OTA solution based on Hawkbit on the server side. So you can do like deployment of all the big updates you're having, and then you have a RAUC integration. RAUC is another open source component we just took and then put some stuff on top of it. That's this OTA, and we're working with Hawkbit. But we also have support for something called NetOTA, which is a really small version where you can just have like a hosted server where you have like your updates, and then you can pull from it instead of having like a complete deployment with Hawkbit, which might be a bit complicated for like small setups. And with that, I have 50 seconds left. Thank you, and questions.
Thank you, Stefan Schmidt. Okay. You have been perfectly in time. So, where are the Oniro developers? What are your questions?
Can you describe how BitBake is like a sausage factory?
No, I can't. You have to ask my boss about that. I mean, the idea is basically that BitBake is a tool that pulls it all together, right? It's like you have this layered approach where you have like all the flexibility of the world. It comes with some pain as well, don't get me wrong, but you have all these possibilities you can do, and that's like a sausage is made by like taking all the ingredients, mashing it together basically, and then putting it together and getting something out, right? And that's what we do. We get all the ingredients, putting it, merging it, and then getting an image out and something to deploy. Okay. I will be at the booth. I will be here until tomorrow lunchtime, so whatever, just grab me, ask questions or something like that. Thank you for your attention, and have a good afternoon.
Thank you, Stefan Schmidt, and we will see us again in 5 minutes for the next speech. So welcome back to our DevOps Track. Our next speaker I asked to the stage is Martin Rabanza from the company RMB. He's a well-known business and technology consultant with 20 years experience in different projects like CERN as a startup as CTO, and he is going to tell us something about flight data and open source liftoff.
Okay, thank you, Johannes. So, welcome everybody to my speech. Thank you for having me. Today we are hearing about flight data and open source. So, see what's happening in the skies. As Johannes already said, I'm a consultant and I'm trying to do innovation projects, helping companies getting their projects done, and then also doing some other stuff, some funny stuff, and this project is one of them. So, what's happening in the skies? If you look at the sky from the ground here, you might see, okay, it's pretty empty there, not a lot of obstacles there, not a lot of trees or roads, broken roads or whatever. But actually, in a plane, it's not like that. So, how many of you know Flight Radar, the application? Quite a lot of you. So, you might know this picture here. So, skies are pretty full of planes, and there is a lot of traffic going on there. And when you are in the air, you want to know what's going on there. So, and it doesn't look like this fancy with all this technology. So most of the time it looks like this, and you have to look out of the window to see other planes. It depends on which routes you're flying, but that's one of the big cases. So the only thing to get to know what's around you or behind you or what's the other traffic is this. So you have to listen on the radio, very old technology, and to listen what ATC controllers are informing you on the other traffic and warning you or whatever. So this is kind of the technology that still pre-exists. And but there must be something newer, you might ask. And this is when ADS-B coming into place, and this is an automatic dependent the surveillance broadcast. So this is kind of a device you have in the plane and sending out your position, your GPS position, your speed, your altitude, and so on. And other planes can receive that. The ground can receive that. So kind of flight radar is working on that data. The nice thing here is this position data is broadcasting on 1090 megahertz. And there is no encryption, so you can read those messages out of the air. There's let's say, no encryption on it, or you have to do some decifration. You can just read it. Of course, there are other technologies like FLARM or Pilotware or FANET or others, but let's talk about ADS-B. So the rules, the nice thing is there are rules, of course. The European Commission, all this comes from America because that's the country where most of the flight stuff is growing, and everything comes from there. But the European Commission implements those rules that every plane on a certain weight has to have this transponder in the plane, and so to send out their position and so on. So, and that's pretty much then what it looks like in a bigger plane when they have a screen and they see other traffic where it is and so on. But there are small planes where you don't have such devices and they are in the same airspace. So that's could be kind of a problem. And we are talking about situational awareness, and you want to know what's going on. So that's actually a photo that's made at the same time. So you see behind the mountain there is a helicopter a bit lower, but on the same let's say, basically on the same course, so there could be a collision. So you really want to know what's going on there. Your question might be, okay, well, what does this have to do with open source? Why is he talking about this? The nice thing is, we said there is no encryption on the messages, and the frequency is in a range where we can get pretty cheap hardware to listen to these messages, and we can create, based on a Raspberry Pi or a laptop or whatever, we can just have an antenna, the normal antenna you use for watching TV on your computer. It's kind of the same signals. So you get them, you use open source tools like Dump 1090, they are on GitHub. You use them to interpret those messages and to decode the signal the antenna is getting on. So you're receiving those messages, and depending, for example, here in Bolzano, you're getting about 0, of course, if there's no plane, to 20 or more messages in the second. So it's pretty a lot of traffic, and it's going on right now, so when planes are there, and it's about 2 giga per day. So it's a lot of data. And this is a very old format. It's a very common format used worldwide, but you can listen to it. So Flight Radar and all the others, they're doing basically exactly the same thing. They're having these base stations on the ground, and they're managing to send those messages to a server and then interpret the data. So this is an example of a message, how this message looks like. And here you see this is message. This is about 9 seconds, 9 seconds of time from 11:34:02 to 09. So no, 7 seconds. Sorry. And here we see the call code. So it's a Lufthansa flight from Munich to Venice. We see then the speed, the course, and the descent rate of the plane. We see the altitude. We see the coordinates, and so on. And it's always repeating. And the blue one, that's a helicopter, that's a military helicopter flying a bit lower. And here the same thing, again, Lufthansa. And then the helicopter is transmitting his altitude, his position, his speed, his course, climb rate, because he's climbing, and so on. So that's an actual intercepted traffic. All of this is perfect to put into a JSON and to use with an MQTT broker. So you can send this data to a server or an infrastructure on a network, and just using those MQTT technology, where you gather all these messages and you store them. In the end, you want to store them into a database. And when you add a few other components, like such an architecture like this, so you have basically here, that's the airspace. Then you have here your ADSB receiver. Of course, in that case, we have one, but you can have a lot of them, like Flight Radar. They have these basic stations all over Europe or all over the world. Of course, towers are also there, but they are not of interest. And then you have here these messages transmitted to your broker using Mosquito, well-known open source project as well, where you have this topic, and you can open the topic for flight data for one receiver, or for 2 receivers, or for 100 receivers. Then you could use Apache Camel, where inside you have these pipelines, and you have connectors to different databases, or REST API, or other technologies where you can expose this data. And using this, you can connect, of course, to the database, or at the same time on an API. And if you want to do this in real time, you use kind of a connector which offers a WebSocket binding. So you could just create a web component or some application or whatever where you want to show on a map the live traffic in real time. And putting all these components together, we are arriving at where you have, or you can create in that case, a component, and you see a map where you really see the planes moving, and you see this real-time traffic where you have then the altitude, the speed, the climb rate, descent rate, and so on. And if you would replicate those kind of boxes or kind of base stations to a wider area, not just Bolzano, but a broader area, you can collect all this data into one and having basically the same product as Flight Radar has. So that's basically it. I have a couple of minutes left again. These components, they are all developed together with the Open Data Hub. So this data is actually arriving at the Open Data Hub, and if someone wants to get this data, and not building boxes, but getting the data, he can just get the data, or getting the data and interpreting the data. And if someone is interested in the components, they are also there. So everything is on GitHub. So if someone is interested to understand how these components work or how they work together, they're all provided as open source. So the Open Data Hub has now a topic where flight data is in there, and it's also offering the web component in the web component store. So whoever wants to use this web component can use it. or if he wants to do some other solution, he's very welcome on doing that. So basically that's it. I'm here for questions if there are some. Thank you.
Thank you, Martin Rabanza. Questions to the speaker? Yes, just a second, there is the microphone coming.
Just a technical question. You have on GitHub also the software for the RPi, for the Raspberry Pi, and some schema to construct, to build this receiver, or just the software that dispatch the messages?
There is also would be a schema to build it up. It's no secret. Basically, it's everything has to be. You have to use some tool like dump 1090, which gathers the message. So basically, it asks the antenna or receives the messages from the antenna, decodes them, and puts them into some text format you can read.
Okay. And the coverage of the one station, the distance of the
coverage?
Yeah.
Well, the coverage is basically line of sight. So if you have a mountain, you won't see over it or behind it. So you see, when you're in Bolzano, you have a pretty good coverage because we have an open valley. If you're in another valley, it's more difficult.
Okay, thank you.
Are there other questions? Nobody handling with flight data? Maybe in future. Okay, then we thank our speaker, Martin Rabanza, and we'll come back in about 7 minutes. Thank you.
Thank you very much.
Good afternoon, welcome back to our DevOps track of SFSConf. Our next speaker is already here on the stage, Andrea Janes. He's a lecturer and researcher at the University of Applied Sciences in Vorarlberg, Austria. And before this job, he spent some years here at Neutech as part of the Smart Data Factory of the University of Bolzano, and he's expert for lean and agile software engineering. Today he will speak about the scalability assessment for microservice architecture. Please, Andrea.
Thanks for the introduction. Yeah, so today I talk about this topic, scalability assessment. I will explain you a little bit what we do in this area and why I present it here at SFSCon. So maybe this slide, okay, don't read it. It's about microservices. So if you know what microservices are, you don't need to read it. In general, I marked the important things like independently deployable services. So we talk about components of an application that you can deploy independently, and they share certain characteristics. Now, I don't have the time to explain it. If you don't know this video from this website from Martin Fowler, there is also on YouTube. Just search for Martin Fowler, microservices. He gives a very good explanation of what microservices are. But for us, here in this talk, it's enough to understand, okay, independent components of an application that run in separate processes and that are independently deployable. So an application might look like that you have a front end and you have different microservices that together with this application solve a certain task. What you see if you start developing with microservices, and it seems, well, since many years there is this hype of using microservices, you see that it's important, and this is, I think, it fits that I am speaking the DevOps track. It's important to use automation to operate such systems. You need some tool to deploy everything. You need some tools to monitor everything because one service could degrade another service. Timing issues are important. Debugging is complicated. If you have a piece of software that consists of different softwares, like different components that run independently, it's hard to debug everything. So one problem that we are looking at is performance, because such a system that consists of moving parts, it is a bit hard to understand from the point of view of performance. So I quickly show you what we do here. We, together with colleagues from Bolzano and from other universities, developed this open source tool called PPTAM. You can find it on GitHub. And PPTAM helps you to define experiments over your software, to stress test your software, and to understand the performance. And I show you quickly the components and what it does. So we have, you see, if I can lift, this is the driver. So we have one small machine that drives these experiments, and we have the test bed, which is a machine where we deploy the software that we want to evaluate. So the idea is we deploy our microservice-based architecture to the test bed. We bombard it with requests, like we generate a lot of fake requests. We look at the response times, and we try to understand at what point our software degrades, doesn't answer anymore, or where the response time becomes too bad for us. So the two important components are the driver that drives the whole experiment or the whole test, and the test bed is the computer where we deploy our software on a test. The rest is like, okay, we store the results in a database and we visualize it in a dashboard. So this is like the overview. If now our starting point is this here, and I explained this a bit now, APM tools. Application performance monitoring tools help us to understand, okay, how is the application used at all? So if we have such a system and you assume that the user is interacting with the front end and maybe one click is causing some kind of interactions here, we can observe the results in these APM tools. So for you, you should remember now from this only that with APM tools, I can understand how users are using the software, and we use this idea for our testing tool. So we first get a picture of how people use a certain software. If the software that we want to test is not written yet, okay, we might take some similar tool or a similar software or a previous version. What we get is this. This is our operational profile, and at the end, it tells you with which probability you have how many users. So this operational profile summarizes a certain application. So in this case, we have 150 users on average, like with a high probability. And sometimes we have only 100 users, and sometimes we have only 200 users. So this is for us a starting point that we get with these APM tools. So remember this. I'll go forward now. So our tool, again, consists of, you should remember, driver, testbed. On the next slide, I zoom in a little bit, but it's not that important now for this talk. It's just that you see that, okay, the testbed, somewhere I have a configuration. I read from these APM tools to generate the tests. The tests are deployed in my testing machine. I test it. I run the performance test and read the response times, and then I store it in a database. Maybe this slide is a bit better so you understand the process. So again, we observe how users use the system. We get this distribution. We choose the tests that might be interesting. So if you know that your software is on average used by 150 users, sometimes by 100, sometimes 200, you can then define the tests that you might find interesting. And then you can use pptam to carry out those tests. So what you should remember, if you have performance issues or if you want to investigate the performance of your software, it might be an interesting tool that helps you to define the experiments you want to do, to find out how quick or what is the response time of the software, and it will help you to analyze or to find those microservices that are slower than others. And how, I explain you on the next slide quickly. So what we do, we make a first experiment with a number of users that are ridiculously low, like 1 user. Your software should handle 1 user. And you get a certain response time. Or let's say 10 users. You start with something that you say, okay, that's for sure, it will be nicely managed. And we get a mean response time for that. Like you use our testing tools for 20 minutes, you run it with 10 users, and you get that mean response time. We assume that the response times are normally distributed. And then we say, okay, everything that is below, if you remember your statistics course from university, everything is below 3 sigma, like 3 times the variance. For us, it's okay. It is like the normal variation that you have in a system. And everything that is an outlier, that is like above this threshold, we consider, okay, here, that's not a random change, that's a slowdown that is more than random. So if we then do more experiments, like we increase the workload, usually your system degrades, and you could even draw such a curve, and you could understand that there is a certain point where you would accept that this is the maximum workload that you have for this system. So in our case, like pptam, we defined it like that. So we do a first experiment, and then we look how much the system degrades, and we can find out, okay, this is the workload that is supported with the tolerance that we want to have. If you have a second system, we do this for all the microservices. So this would be an example of another microservice. It has, from the beginning, a slower response time, so it's above. It has a bit a narrow distribution, but we even say something that we see also here, something we observe sometimes, that if you increase the load, it becomes faster, because there are some systems that suddenly enable another replica, like if you have it on Kubernetes or on Docker, it might be that after a certain number of users, certain mechanisms start, and the average the response time gets better. But after a while, all increase. So what we do now, last 5 minutes, concentrate. If we have, let's say, this operating point, we would like to serve this number of users. What calculation do we do? We say, well, you see it in a picture. Both are in the green area. Why the green area? Because we take for both services the average, add, so if the sigma is that, we take this number plus 3 times this number. So this is the maximum value for the response time that we accept. And if it's below, it is below here, it is below here, no, here it is below, yes, we say it's a pass. So we do exactly what I explained graphically. We take the average, we add 3 times the sigma, And if it's in this green area, we accept it. Why 20% and 80? Remember this tool at the beginning that measures how people are using your system. When somebody uses software, you don't use all the components equally. This tool will tell you, okay, this component is used 20% of the time, this component is used 80% of the time, so we consider that. In this case, it's easy because we have, like for everywhere where you have a green pass, you add the percentages, and we have 100% success rate. In the next example, if you want to operate here, this one is completely out, it's in the red area, and this one is in the green area. Numerically, you will get these results in our tool, and this will tell you, okay, like we make this for every microservice, and then we sum up only the success rates, only the percentage of calls for the microservice that are successful. This is useful to get like one number that describes your whole system consisting of many services. So what we get at the end are such curves. Like we can then say, for a certain architecture with a certain amount of memory or a certain number of CPUs, if you run our tool, you get this pink curve. You get a success rate of 100% for a certain time. And after a while, some services become slower than 3 times sigma. And then we have to decrease this success rate, and you get such a result. This is another architectural alternative. Like we tried to test a system with fewer memory. Like we reduced memory from 16 gigabytes to 8 gigabytes, for example. And you then see that the different microservices degrade faster. Remember this operational profile. This is the curve that tells us what the users really do, like how they really use our system. So what we do, we take this and that and multiply it. So this is the combination, which means, because the success rate is a percentage, and this now, the multiplication is like the portion of the usage of our system that is supported from a performance perspective. So they look a bit complicated, these curves, but they tell you, like of what the user requires, which is the operational profile, of what the user wants, you can see the part that your system is able to, let's say, support defining that too slow means like starting from a low number of users and adding 3 times sigma. Okay, so this is what PPTAM helps you to do. Where do we want to go from here? So this is already, like if you go to the repository, you can use it like that. Where do we want to go? The next steps, we want to identify performance anti-patterns. So if you have a software and maybe you know it, or you had such experience that slows down sometimes, suddenly, like it gets slower and then it gets faster. And maybe one day it's slow, another day it's fast again. So these are called application hiccups. There are then other different anti-patterns, like let's say the Stifle data is retrieved through many similar database queries. Like instead of one proper query, somebody is making thousands of little selects and then aggregates the data on the client side. Like such things we want to observe in the next version of the tool. But okay, I hope that I gave you an overview of what PPTAM is. And yeah, if you're interested, write me or download it and try it out. Thanks.
Thank you, Andrea, for this interesting insight. So there's no time for questions, but you participate also at the hackathon, and I think afterwards, so it will be still available.
I am around, yeah.
So and then with this, we stop here for the 5 minutes break for the preparation of the next speaker. See you again in a few minutes. Thank you. We are trying to reach him and ask. Oh, welcome back. Now our cybersecurity expert is here. That means he has a lot to do. So cybersecurity is a hot topic. So he's a senior project manager at DSA. Please, to you the floor.
Okay, thank you. Good afternoon. I'm very sorry for being late, but I was sure it was 15:20. Okay, the slides
are coming.
Okay, we are in the end. Can we go back to the first slide? Okay. Good afternoon. I'm here in Bolzano for the fourth time to speak about open source or free software-based digital forensics. For who doesn't know what is digital forensics about, the first slide, please. It's the field of forensic science that applies to the digital investigation. I work with law enforcement mainly to investigate crimes committed with digital tools, crimes where digital device is a target, or crimes where digital device is a witness. That is the most often case. And this talk in Bolzano to raise the awareness, because in digital forensics we play with life of people, okay? So we mainly, in many times, okay? Many times we have to use proprietary and closed source tools that relies on exploit, on zero-day that we will never know anything about it. Okay, we have to trust the producer that the particular device, so this particular software, it's affordable, reliable, but we cannot have any evidence, any proof. We can also compare the results from one tools to the results of another tools. I call these black box forensics. Okay, you have black box, you put something in, you got something out, you have to simply to trust. I don't think this is a correct way to do forensics. I think that there are a lot of tools, a lot of knowledge about digital forensics with free software. So I'm trying to make a lesson a year here in Bolzano, and also when I work at university, to spread awareness about what is possible to do with free software in digital forensics. This time, we're talking about a device that was originally designed to fight stalkerware. Stalkerware is a class of application made to spy on someone's device. Okay? For example, you can get for another device position, text, or any other data without knowledge from the owner of the device. It's a terrible way to abuse of someone digitally or other than just physically. And if you think about it, it's terrible because this application, these apps are freely available on the web. You can find a lot of them easily. You can install, not you, I hope, not you. It's possible to install on your partner's phone without he or she has any knowledge. And believe me, leaving just a few traces, it's very difficult to identify stalkerware on a phone, okay? Without a deep forensics analysis. A couple of years ago, in 2020, this guy, Felix Aimé, had an idea. He was working as a volunteer with the women's shelter. You know about that, okay? I hope, not because you have been there. He was looking for a tool to identify stalkerware on the devices. The main idea, and he created a tool called at time TinyCheck. The main idea behind TinyCheck was that if a stalkerware app has to communicate data to another device or to a server, it must use the network. Once you begin studying stalkerware, you can identify IP addresses, remote web addresses, remote servers to which the stalkerware connect to transmit the data. So there are also a lot of other elements that we call IOC, indicator or compromission, that you can find on a device. Okay, you can find the traffic that the device makes. But mainly, it's important to trace the traffic, the IP addresses. Felix made a system based on a Raspberry board, the PI4, that the board, the 4, has two networking interfaces, one Ethernet and one wireless. You had to connect the wireless, the Ethernet interface to the internet, as usual, to your router, anything. While you can use the wireless interface to create an access point, okay? You connect the device you have to analyze to the access point. From this moment, the device keeps collecting all the traffic the device makes. Okay? You have to do some basic operation because sometimes stalkerware switch on, power on itself when the phone is powered on, when you make a call, when you send a text. There are some events that triggers the stalkerware. Okay? So you make all these operations while connected to the access point made with the Raspberry. The Raspberry records all the traffic. After recording all the traffic, it's possible to analyze the traffic, find the IOC in the traffic, and give a report. There's something like that. In the worst case, it's the red screen. You will discover that your device has been compromised. Okay. From now on, there are many different ways to clean a device. The one I strongly suggest is to drop the device in the bin. Okay, because you can never be sure that the device is really clean. Let's come to the forensic part of the tool. Why I'm here talking at Free Software Conference about a device that fights stalkerware? Because being the device is completely open, being the source code completely available, being Felix a very beautiful person who can answer, who will answer you a lot of times on direct message on Twitter with and no problem. What I made some modification to the TinyCheck then, SpyGuard now, enabling the firewall on the Raspberry, on the Ethernet interface. And authorizing, there are a lot of apps on your phone, like Telegram, Google Drive, Google Mail, a lot of apps that have their data in the cloud. Okay, you don't, for Telegram, for example, all everything, excluding the private chats, it's in the cloud. Okay, we in forensic use a lot the cloud to get data. Many times it's simpler to get data from the cloud than from the device. Okay, but you have to be sure when you access data on the data on the cloud that nothing else comes to your devices. Okay, so I switched on the firewall on the Ethernet interface and authorizing a set of addresses, external addresses to connect. For example, Telegram. I searched all the IP addresses that the Telegram servers use and authorized only these. In the end, you have a device that can connect to the internet that allows your device, your mobile phone, your laboratory device to connect to the Telegram servers. So the scenario is that you have a device of the suspect. You have to analyze Telegram data. You put the SIM card of the device or the suspect on your lab device. You can connect, install Telegram on the device, connect to the internet with the SpyGuard modified, and recover all the data, all the Telegram data on your device. Okay. In the end, you will have a lab device with the Telegram data or any other apps on it, and where it's easier to extract the data. Okay? And on the SpyGuard, you will have the recorded all traffic in Wireshark format that you can add to your forensic record. Is this method forensics? We can say enough, because we have collected the data using the suspect identification, SIM card. We have collected data without any interference. We have recorded all the traffic data, so we can be quite sure that we can present our device, our data, or the media extracted from Telegram in court being forensically sound. Eventually, you can make a forensic copy of the device, and you have to store everything respecting all the forensical methods. For example, you have to guarantee integrity, you have to guarantee chain of custody, and so on. So, I'm very sorry because I was late last time. You can use a public available code, a board, to make a forensic device that can help you in a lot of cases. There are a lot of forensics devices that do the same thing, okay? But they are not open, they are not free, you don't know what they do, and it's not last, they are very expensive, okay? Here, you have to buy just the Raspberry board and nothing else, and you can have your device to analyze, your forensic device to analyze the traffic. Okay. I speak a very bad English, and I know. I don't want to leave you with bad memories. I leave you with kittens. So you will remember the kittens.
Thank you, Alessandro Forina. It was good English, and it was also a very good conclusion. So he's available, I'm sure, for the next hours also for some direct questions for you. So, and now our next speaker couldn't participate, so we have a 15 minutes break, and we can see again at 3:40 p.m. here in this room for Ettore Chiamenti for the next contribution on the topic of Oniro, how to an open source project can revolutionize the IoT market and industry. See you soon. Good afternoon. Welcome back to DevOps Track of SFSConf. So we say hello to our next speaker, Ettore Chiementi. He's an embedded Linux developer and works as software engineer at the company Seco. Today he will present how an open source project can revolutionize the IoT market and industry. Please, Ettore, for your contribution.
Thank you, everyone, and welcome to the FSCon, and thank you for attending. And today I will show you the Oniro project, and I will explain how the an open source project can revolutionize the market, the IoT market. So, and let's start. So I'm Ettore Chiementi. I'm a software engineer at Seco and an embedded Linux, and I'm responsible for the hardware enablement in the Oniro project. So Seco is a device maker company and is involved in many open source projects, including Oniro. So I will talk about a little bit about the fragmentation in the IoT world. So in the recent years, we are witnessing a large increase of the IoT devices in the market, and is increasing at a really fast pace, much more than the consumer market. So this leads to a series of problems that it's affecting the IoT market. So one of these is that there are too many devices to maintain actively. So for companies, it's hard to make them secure, since they are always connected to the internet. Another thing is the technology is evolving so fast that companies are not connecting together, and this leads to technology silos. So it's the devices cannot interact with different vendors, for example. We need there is a need of an orchestration that is capable of guaranteeing vendor neutrality and openness, because as I said, companies doesn't have a standard for communicating. Of course, there is a lack of an open source end-to-end solution, so there is no standardized way for development in the IoT. And last but not least, the communication between devices is always, or at least for many technology, is achieved with connecting to the clouds. So for all of these reasons, we developed a solution that is called Oniro, hosted by the Eclipse Foundation and it's a distributed operating system, a platform for creating apps and application for the IoT world. And it's made for a wide for many type of devices, big and small. So how to fix the fragmentation problem with Oniro? We try to develop a common code base that is specific to IoT project. So it has all the features that that are required for making an IoT application. We try to standardize the workflow for developers to make their own applications. We try to bring back the communication at the edge between devices, so not using the cloud if it's not required. We need an open collaboration between players, so that's why it is hosted by an open governance as the Eclipse Foundation. And we don't want to reinvent the wheel every time. We don't want to revolutionize what we have been doing before. So we are just connecting the pieces between existing open source technologies. So one of the key features of Oniro is being based on the Yocto BitBake building system that can exploit the flexibility of the system to make images that goes to the devices on top of Linux and Zephyr. So we can use the same building system for targeting microcontrollers or single board computer, for example. In the terms of filling the gaps, we are using, for example, for the over-the-air updates, we are using Hawkbit as the update server, Rauk as the update runtime, and all of these pieces are orchestrated by a wrapper that is mainly the active part of updating the images and the devices, and this can be configured to use also other types of updates. So this gives to the user, to the companies that are willing to use Oniro to use also different approaches to this system. And we also tried not just to do the code, but to build something that is production ready or production grade for the developers to adopt Oniro and start using it. So we build already an infrastructure based on GitLab runners. So at every commit that we are doing in the code base, it will be tested against the devices that are under test, and we are testing the IP compliance and other certification to be production ready. As I said, for example, IPM-FOSS is really important to be open and accessible by any company. So we are doing a FOSS scan to be compliant for the license to be open. And what you're getting from Oniro. So we are building a core that everyone can exploit. So we are reusing open source software core like Open Embedded. We are using tool chains, core libraries, application frameworks, and the Yocto core. And on top, we are building CI/CD, testing, documentation, maintenance, IP compliance, OTA, and security. And some of the, for example, some default configurations, hardening of the kernel, and the management. On top, you can customize the building system to add some of your configuration and, of course, your application. So your effort is reduced by more than 80%. To build it by your own. As a device maker, we are getting some of the industrial reference hardware, so you can use it for your industrial application. So we introduced an Intel and an AMX8 and cost-effective ROC chip to wide the type of application that you can do with IoT in the IoT market, as well as some standard prototypization devices such as Raspberry Pi or virtual targets like QEMO. This permits us to show to companies also the real life applications like blueprints. So it's like a service design for an application. So you can look how we did this vending machine. It's like a demo, but you can also try to see how we implemented it, like how can be implemented in Oniro. And so this is why we have some of the real hardware for reference. So what is the added value of being a part of the ecosystem? One is that you get a co-investment with the other partners of the working group. You get to be in a global ecosystem, so we can share knowledge and know-how on different areas of development. We have a shared go-to-market strategy because on top of this, Oniro also creates a way for creating new application, and as for example, a system integrator is really useful to adopt it for your clients, for example. There is a unified set of configuration, APIs and protocols that you can exploit, and you have everything bundled inside the Oniro ecosystem. And you get to development and deploy your application inside the working group, for example. So the project has started 1 year ago. So its first birthday happened last month, and there is the next release is going to be out soon in the next weeks. So you can already go and find documentation and try it out on your computer, for example, to start develop with Oniro. And we have a channel in IRC, Libera Chat, so you can interact with the developers. And of course, there is the website, and we have also a booth in the hall if you want to know more and see one of the blueprints. There is CATS, is one of our blueprints that we have been developed. And yeah, thank you, and I hope you join the community.
Thank you, Ettore Chimenti. Other questions? So if no, I have a question. Was the happy birthday party already celebrated of Oniro?
Yeah, of course.
Of course, okay. Otherwise, there is maybe the occasion also these days. And okay, so invitation, so visit the booth of Oniro, and we see us for our next speech at 4 o'clock. Thank you.
Thank you.
Welcome back to the DevOps track of SFSConf. We say hello to our next speaker, Gabriele Scarton of the company FOSS Group. He studied computer science at University in Trento, and he's now a software developer for FOSS. Please, for your contribution.
Thank you. Hi, everybody. I'm Gabriele Scarton. I'm a software web developer. My main topics are IoT and Java developments. For IoT, I work with Raspberry and ESP32 devices. I worked in many research projects in group with other companies, and currently I work in agricultural and environmental project and electric mobility project. I work for Group of FOSS. As stated in the name, is a group of company, TNG for engineering, FOSS Green Tech for technology transfer and innovative startup, the operative holding FOSS for software and IoT solution, Web Group of FOSS for international project, mainly in Lithuania, in Rebus in Torino for digital learning, and Nile Solution in Milan for data center. We do integration and software development services, telecommunication services, my area, research, development, and prototyping of innovative technological solutions, and also application infrastructural outsourcing. The topic of this presentation is to send data from a Bluetooth beacon to a control station. It seems like a simple goal, but for the Blues Lemon project, we needed to use the beacon, place them in the landslide, and monitor the position of the beacon to monitor the movement on the landslide. The problem was that the open beacon provided by the market are not so open, because the beacon connects with the control station with Bluetooth, but it connects only to the manufacturer control station, which could be an app or a software you have to install in your device. And then this manufacturer control station provides you APIs to do what you want with the beacon and APIs. The problem is that you don't have the full control of the beacon, because you have full control only on APIs. And also you need another connection to use the beacon, because for example, some manufacturer save configuration data of beacon and data on internet. So at least one time you have to use internet with the manufacturer control station to register the beacon. So in BlueZemo project, we started to analyze the beacon to get more data possible and make an independent beacon. The first part was get the Bluetooth data. I will go fast for this part, because I already made a FSCon presentation about how to get Bluetooth data on Bluetooth beacon. If you scan the QR code, you can get the presentation, or you can search in the SFSCon website. The main topic of the Bluetooth data is that the advertising Bluetooth low energy packet are free to scan without pairing, so you can get the ID of the beacon, the MAC address, the RSSI, which measure the quality of connection of the Bluetooth connection, so you can make some estimation on position, and manufacturer data. For this presentation, we focused on how to get sensor data from the beacon. For the beacon, we choose the ESP32CAM device, because, of course, it provides Bluetooth connection. And then it has a nice feature as GPIO pins, so you can connect sensor with I2C. You get a connector for OmniVision camera, so you can get photo. It has a micro SD slot to save data. It has an adapter with micro USB, so it's easy to develop with them with a computer. It has an open source SDK, the ESP IoT Development Framework, which is open source and available on GitHub. And this framework is based on C language. Or if you want to do something easier, there is also an Arduino library to install to program the device Arduino style. So for setting up the device, we started from the Bluetooth server example from the GitHub page of the software development kit of ASP. The idea is to set up a GATT profile. A GATT profile is the basic standard of connection of Bluetooth. And it has a profile which defines a service, and then the service defines characteristics. The idea is to be as simple as possible, so to set up two characteristics. One from receiving data from the control station, and one from sending data back to the control station with the sensor data. So after we set up the beacon with the server configuration, we have also to set up the control station, for example, a Raspberry or a Linux computer with Bluetooth enabled. And we have to save the Bluetooth MAC address of the beacon to connect with it. and the GAT UID, the universal identifiers of the profile, which we declared in the beacon, so we can communicate with it. The idea is to make a loop cycle on the control station. The idea is to wait for when the beacon is connected, is to wait from data from the beacon for some time. If we not receive nothing, we check if the command for the beacon arrived. If a command arrived, we send it to the beacon and repeat with the loop cycle, waiting for the response. We tried some framework for this loop cycle. At first, we tried with Bluet, which is the standard C library for Linux for Bluetooth. The problem of Bluet is that it's not meant to be used as a script. It's very difficult to program it as a script because it's very low level. The interface is only for writing command on a console and see data by hand. So we switch to BluePy, which is an open source library available on GitHub, which is based on Bluet, but it's easier to manage. The problem of BluePy is that it's not maintained, so it has some bugs, and at the moment it doesn't provide all Bluetooth Low Energy data of the packet. So with BluePy we can get sensor data, but we don't have the RSSI for estimate the position of the beacon. So our future improvement is to merge the Bluetooth scanning already made with this GAT profile communication with ESP32 to merge them and finally have a beacon which is completely independent from the manufacturer, because you can get all the data from the protocol and from the scanner. This is the end of my presentation. I'm open for questions.
Thank you, Gabriele Scarton. So, are there questions? Second, that Claudia brings you the microphone.
Hello, thank you. So, do you use any Bluetooth mesh functionality here, or is it always a point-to-point communication between the controller and the beacons?
No, it's one-to-one communication, no Bluetooth meshing.
Okay, so there's like a limit in like how far you can get away, like for your whatever use case you're having, like you have to have a controller nearby the Bluetooth beacon to actually get the data.
I don't understand.
So the idea of like, I was wondering, like, if you have a point-to-point communication, you have like outdoors, you maybe have like maybe 100 meters or something between the controller and the sensors. So there's no way to extend the range of that with a mesh or anything.
Okay, no, at the moment it's only the control station which communicates directly with the beacon.
Any other questions? We have still some minutes. Otherwise, we can also stop here. Thank you again, Gabriele Scarton, and we'll see you. We see you in about 8 minutes for the next speeches. Welcome back to the DevOps track of SFSConf. With me is our next speaker, Roberto Innocenti, president of the Power Progress community. And he has a very nice title of his presentation, so start, enjoy yourself with open hardware, which he will introduce now.
Thank you.
Please.
Thank you. Okay, enjoy. The idea is to enjoy, because this project came from a long time ago, 8 years. The project to develop open hardware and related to Linux. No? We are a non-profit association registered in Italy. All volunteer are all the people that collaborate are volunteer. We don't make any commercial activities. So we like to design open hardware directly or paying with for the development, for the design. We reuse and dismiss low hardware for the school, for teaching, for Scratch, for coding. In general, we push, encourage people to use free software, and we are open even to open science, even if it's something for the future, but is on our DNA. We are hobbyists. We are not engineer in general. We are not engineer of hardware. We have few of us that have some knowledge. So we are self-financed as association. So we have in these years not a fixed schedule. Depend from the donation, from the collaboration. Time by time, during these 8 years, we move our step slowly. Sure, there is a feeling of rebellion about the situation of closed source, of situation where we have only particular hardware that is not open. In any case, our project was very difficult because, for example, build up a motherboard for a notebook open hardware is not simple, but we have a passion for this common goals, and we try in our steps during the years. Here's some picture. There is even Diego sit down. And recently we tried even in other place to share this project and other projects. And with a short history, we established the association in 2016. And during the following years, we have done different steps: the design, the schematics, the decision of which components, so the the campaign for hardware test, because we're still waiting our prototype, because this month probably, I'm quite sure we have in our end the prototype, not only the 2-layer PCB like this. So we do even other activity, some related to the software, porting software, or in any case make run smoothly software on PowerPC architectures, but even other projects like some cases are only embryonal, like an open notebook chassis, like another more simple board, like this is not something new. From 5 years we make education with Scratch with reused notebook. And so I want to talk about another foundation that is more bigger, that is Open Power Foundation, that is launched in 2013. We are one of the members. There are even companies like Google or other in this foundation. Is a no-profit, and its focus is related to open hardware. So in 2019, power architecture was open like RISC-V, and so there is the Power ISA that permit people to make a new silicon without royalties. See, it's something not new. I mean, Power is an architecture that is from 30 years, so is a proven architecture. And so it's possible to have a different, for Open Power Foundation, want to write down technical papers and reference design. It's not only theory, even something concrete. And so this is the Open Power goal is to stimulate this environment around power architecture, Power ISA, open hardware. In this way, they simplify for many little companies the possibility to adopt new hardware, and so is helpful. For our point of view, was helpful in terms of relationship, in terms to have the possibility to share our project, even if we don't use an Open Power chip, because actually it's not already in mobile sector, but is in server sector. But in any case, we are welcome in any events that Open Power Foundation do. So with future chip, they do even other more less power hungry processors, so IoT, storage, automotive, and so on. So it's different from now that are servers. And I have already tell about there are different working group. You can take a part to technical work group and to special integration group. That in one side they write technical specification, and the other type of group try to make the demonstration tools, the demonstration hardware. No? The participation is open. So in fact, actually, power processors are not used in I don't know, very small motherboard. In fact. Even our motherboard is not so small, is not so cheap, but thanks to the Open ISA, it's possible like to upload in this FPGA a new Open Power processor that is the same that run Power 9, Power 10 processor that are very, very strong. So this permit another type of adoptions about this kind of chip. There are even not only via FPGA, but even silicon with ASIC. For example, I have tried, but this is arrived to me yesterday. Usually I don't know anything about FPGA. I tried to prepare the Power PC. No, I was not able because there is an error about a closed software that is by Vivando. So I think the next FPGA should be even open, even the FPGA, not only the product of the FPGA. No? Anche FPGA should be open. So next goal, not my goal, because I have no experiences in that. In any case, Microvat permit to try to install this, even smaller FPGA. LabreSoc have done a very interesting demonstration even on silicon not so miniaturized, so 180 nanometer, but in any case have realized the silicon. And the Red Semiconductor is starting developing new chip around this open power chip. So it's something that is in evolution. You can see a fabless project where Anton Blachard, Microvat, have asked to produce the chip itself in silicon, not only in FPGA. No? There are many other chips, but only to give you an example. This is another card, an FPGA a little bit more big, more strong, but you can run in that FPGA. We can run even MicroPython in this node because it's too much smaller in terms of RAM. This is the CMOD A735 is this. As I have tell is very little RAM, a flash very little, but I hope I can complete my trying to install with more time, because was very difficult to do in so few time without any kind of knowledge. There are tools very useful to make silicon in this way. I have only for your information, share Lytix, OpenCore, MiGen, but I don't know exactly all kind of application. I have not experience on that. MicroPython, I've understood that is another way to program microcontroller, even this soft core that is different to programming C, C++. And so I have tried to do that, install Vivando, install FuseSock, build the kernel and so on, but I have some error in Vivaldo tool, so at the moment I was not able. But if someone of you can want to take a part, I'm happy, because I have not so much time trying something that I have no so big experience. There is even a library BMC that is a card that monitor and manage other server that is already working. No, is made with FPGA, but is a real product. Is not a demonstrative concept. So the milestone, this is the dummy board, coming back to our particular activity of our association, so Power Progress Community. So it's designed around a particular notebook, so we have not reinvented the wheel, but we have selected a notebook chassis, and we have designed the card to put inside. No? We are following the step of open source hardware certification. We will do the certification itself only after we have tested that the prototype works. So actually we have not in our hand. We will do the certification after. This is a particular architecture, so we must thank open source, free software about the possibility to run Linux and other applications on a different architecture. So without this, it was very impossible, this goal. These are a few characteristics. It's not so updated because it's a processor that is born in 2015, not updated. So we have added SATA 3, USB 3. So it's not the best technical solution, but it's something that have particular ethical way, so the open hardware, the Linux, and so on. So for us, it's count more than to be very performant. This is the real chassis. It's a gaming chassis. It's good because we have a changeable video card, so we need space. This is exactly the video card that we put, but we can put another. We have selected AMD because there is, for our point of view, a more simple support. Yes, the idea is not to do something simple, because in any case is an architecture that is not used in consumer, so you have some difficulty. If someone want to try, you know that must do something sportive, something is not to stay on the sun, is moving. So actually we need even an help regarding the bootloader that is open, but we have patched a little bit on our dev kit, but we need to check with all the peripheral, the controller inside this board. So if someone have competence can help, is welcome to help. So I have already tell this. We have even the idea to make a seminar in Tech High School, university, regarding this way to operate in open hardware way, and try to stimulate the forking, the design, to make a simple design or different design. So even as I have asked you, if you would like to play with FPGA, you are welcome. And our association have a different point of reference that you can fill a survey to participate. And okay, I want to stop. Do you have any question?
So where are the hardware developers?
Here
is a question.
Okay. No, we are hobbyists.
Yeah, I want to know how are the benchmark performance of.
Is are 8 thread with 1.8 gigahertz, so it's not so high the gigahertz. So I can tell you when I use our dev kit that is outside, that is less powerful than that. And I think it's quite usable, but I think if you make a test with so i7 is less powerful, sure.
Okay.
But fluidity, I don't know. Fluidity of task, or threading, or multitasking, I don't know. We will see.
Okay. Thank you.
Thank you.
So, thank you, Roberto Innocenti, for your presentation.
Thank you.
And then in front of this room, there is the table also where you can study this electronics. So, we will see for the next speech in about 5 minutes. Thank you. So good afternoon. Welcome back to the DevOps track of SFS Conf. With me are two speakers for the company Evo. It is Andrea Avancini and Diego Bernardi. So they are software developers, and they will talk in their contribution about how to use agile and open source to develop custom IoT systems. Please.
Thank you. Oops. Good afternoon, everybody. I'm Diego. We are Diego and Andrea from the Evo Digital, and we would like to share with you how we use agile and open source technology to develop our custom IoT system. Just a brief introduction about Evo, our company. Evo creates and produces lightnings for applications such as architectural lightings or street lightings or large area lightings, in example, airports or sport field or sport zone. We work inside the digital department, and what we do in the Evo Digital is to bring the smart or the connectivity capabilities to these luminaires. This is an example of our actual ecosystem. Starting from the luminaire on the top right, we have the light. Inside the light, there is usually an LED driver. And connected to the LED driver, we have our smart module, which is an embedded device, custom-made, which basically, these devices are connected each other via a wireless network, so they can exchange data and messages. And usually, one of these devices is connected to a gateway, which provides internet connectivity. And on top of that, we have the control plane, from where the users or the customers can basically see the status of the luminaires, can create statistics related to the data of the luminaires, can receive notification in case of failures or alarms on the luminaires, of course can create scenes and control the light. Here you can see also a couple of examples of the open source technologies that are involved in this ecosystem. The digital department of EVO is made up of different departments or teams. So I work mainly in the hardware and firmware team, where we develop the embedded devices. The software team, Andrea, in this case, mainly work on the back-end, front-end, or the software part. And then we have the customer success team, which is in close contact with the customer, from where mainly the request for new features came from. So how can we usually handle the development of a new feature? Let's see an example. We already have an implemented solution and developed solution with a luminaire. And basically, we receive an example to integrate a new projector or a light in our smart ecosystem. This means that the customer has to be able to see the data of this new luminaire, and of course, he has to be able to control this luminaire. So what we do usually is to do an estimation. Both the team perform an estimation of how much is the effort to introduce this new projector. In this example, the hardware and firmware team estimate 4 weeks for the full integration of this projector, and the software team estimates 1 week of work. So as a summary, the full integration of this projector will require 5 weeks in total. So how can we usually plan these activities? What we do is that we do refinement. So we try, starting from the 4 weeks estimation of the hardware and firmware team, we try to split them into an example. This is an example into more shorter and more manageable activities. So here we split the full integration in one task from where we will collect the data from the projector, and we will expose this data on the graphical user interface. This will require 2 weeks, and the control of the projector will require an additional 2 weeks of works. The outcome of this refinement is that we add on the software and the hardware firmware backlogs, team backlogs, these 2 activities. So they are ready for the next step, which is the planning of the activities, usually the sprint planning. Please, Andrea.
Thank you, Diego. So basically, Diego explained how we basically try to understand and plan the activities, and then the next step is to actually organize the development activities, starting from the backlog that were shown in the previous slide. So first of all, we start from the sprint planning for the hardware and firmware team, and our sprint is a chunk of time that is 2 weeks. And of course, on top of the backlog, we have two actual issues. The result is that we put in the sprint, in the actual sprint of 2 weeks, the first of these 2 issues. It collects the projector data. In this case, the team confirms the estimation that was made during the refinement and also the previous activities. And it's 16 story points. For us, it's story points. 16 story points means 2 weeks of work, 2 weeks of work in this case. As you can imagine, we cannot add any other issue to this sprint. So the hardware and firmware team will work only on enabling the collection of data from the new projector. The result is that we cannot actually integrate the full integration of the projector cannot be achieved in the sprint because we don't have space to put the other issue that is actually controlling the light from remote. And in this case, however, we are able to give some value to the customer because the customer can start seeing the data that are collected by the smart module and send back then to the control plane in order to at least start to collect data. You can imagine that the projector works by itself in a standalone mode. we miss the possibility to control it from remote. This will be done probably in the next sprint. Similarly, for the software team, we do the same thing. Since the activity for the software team was a little bit smaller and manageable, was estimated by 8 story points, and the team confirmed it actually, we can add other features, other bugs, as an example. Also, in this case, the result at the end of the 2 sprints is that we give a value to the customer. The customer is able, as I said, to actually see the data coming from the projector. Other things that we do, other agile methodologies and approaches that we use regularly, well, every day we have a stand-up in the morning, both teams separately. What we discuss here is that every team member tries to explain the others what he or she did in the previous day, what there will be the activity for the current day, if there are slowdowns and so on, trying to solve and ease the work for everybody in the team. To track the progression of the issues, we use a Kanban board, like the one in the example. We have columns. The issues flows from the left to the right. Once they are at the extreme right, it means that the development phase is done, but also that specific task has been released to production. So it's actually on top of the smart module or in the control system. What are the mechanisms that we have to evaluate the functionalities that we implement, and also how can we collect feedback? Well, the first thing that we have is that we have continuous integration and actually continuous deployment. What we do every day, whenever we start a development activity, a software developer creates a new branch in our Git repository, and what happens is that anytime he pushes, then a build starts to validate actually the changes. Once we are ready to merge into the master, what happens is that we start integration tests between the 2 parts that was described, so the smart module and also the control plane. So we have a set of integration tests that cover the most common use cases that we have to actually test the integration. We have Seleniums to test the interface, the user interface, the GUI that we have of the control plane, and we actually use Ansible and AWX to perform continuous deployment. So after the build is done, we actually deploy the changes into production directly without any manual intervention. This is actually a screen from our GitLab pipelines, actually. Furthermore, to spread the knowledge of what we did and also to collect feedback, at the end of each sprint, the last day in the morning, usually, we do a sprint review. All the teams that are part of the business unit, Evo Digital in this case, participate to this sprint review. Also some of the stakeholders, if they are available. What we try to do is to show brief demos of what are the new features that we introduce in the current sprint, to collect feedback actually, to shorten as much as possible the feedback cycle that we have with our stakeholders. And of course, also the last day, but in the afternoon, each team does a team retrospective. This is actually my favorite part because it means that we are closing the sprint, not always successfully, I have to say. And here we try to discuss of what went well during the sprint, what could be improved, ideas that we could try out, technologies, but also changes in the process and so on. And also we allowed people to thank the others if there were something that was particularly difficult and a team member helps another one to solve a technical challenge or other things. This is actually cool because once I came to the company, the retrospective was really, the mood was not very nice, let's say. All the people were a little bit afraid of speaking. Then, using a tool that is available online, we introduced an icebreaker. So people started talking about personal details and so on, and now the mood is very nice, actually, and it's a moment of bonding also, not only discussing about the things, the technical things, let me say, but also sharing moments with the team members. And that concludes the sprint, because this is the last activity in a sprint, and you can imagine that this cycle restarts. Again, refining, sprint planning, and so on and so forth. And this is how we try to manage actually the integration between two different domains, let me say, and also using Agile to allow us to achieve good results, nice features, actually, for our product. Thank you very much.
Thank you to our speakers for a nice insight in their Scrum methodology. Are there questions for our speakers?
What's the calculation behind the story points you have for each implementation you have?
Actually, we try to at the beginning. It's an interesting question. At the beginning, we try to avoid using story points, to be honest, because we actually don't like estimation, because all the time estimations are wrong. And we tried a lot of mechanisms to understand how we can use this estimation, because when we do the planning, it's easy to put the things together. But then we discovered that for our team members, it's actually easier to map a story points on a single day of work of a single person. And then the idea was to go in this direction. So it's a power of 2, but we use 8 story points, let's say, to say 5 days of work of a single person, 16 for 2 weeks of a single person, and so on and so forth. In this case, we cheated a little bit because it was for the whole team, just to give you an example, but usually it's like that.
Other questions?
Which tool are you using for managing sprints? I think GitHub.
Well, we use GitLab for the continuous integration and continuous deployment, and for hosting our repositories of Git. It's a self-managed instance of GitLab, actually, that we have in the company. And for the Kanban and for the issues and so on, we use Jira, Atlassian, let's say, and yes.
Okay, thank you. The time is over. I invite you to contact afterwards our speakers, and thank you again for your nice contribution.
Thank you.
See you again in 5 minutes for the next speech. Welcome back to a DevOps track of SFSConf, and welcome to our next speaker, Marco Marinello. Marco is a freelance specialized on system administration and system integration, and is the president of a Linux user group of Bolzano. Today, he will present us H2 Square proxy, right? Please.
Thank you so much for the warm introduction. Welcome also from my side here at the SFSCon. Today I'll present you the H2 Square proxy project, which is, as the subtitle says, an Ansible Swiss Army knife to manage your highly available front proxies. So a few words about myself. I'm a freelance developer and system administrator, president of the Linux user group of Bolzano, member of the Document Foundation, and also contributor. And I'm the former FUS project technical partner. I'll introduce you to why of that. It's because H2 Square proxy was originally developed for the FUS project. It was the part of the pandemic time in which services that the FUS project already provided their users with needed to scale up to many hundreds of concurrent accesses in a short window of time. So it's a set of Ansible rules. If you're familiar with Ansible, it's basically a set of rules for Ansible to configure hosts in a specific way. It's a tool used to deploy the HA proxy tool. Includes a certificate management routine, and it's also useful for business continuity and disaster recovery infrastructure. So what can H2 Square proxy do for you? It's an effortless SSL certificates replication. So it can effortless replicate certificate between multiple proxies, and was the main idea behind the development of this tool. Supports certbot hooks for renewals, so that when you need to renew an SSL certificate from Let's Encrypt, it automatically gets deployed to all nodes. Balances incoming connection between multiple application servers. Of course, it can also distinguish between different applications on a domain basis. You can use it to roll out HA proxy upgrades not only from the packages point of view, so upgrade of the binaries, but also from a configuration point of view. And it enables you to add, remove, or edit domains in a matter of seconds. So let's see the most basic use case of this tool. You have a public IP address that is terminated on the primary H2 Square proxy server, and you can round robin the incoming request between two application servers. So you're introducing your infrastructure, a first step of scalability. As I was mentioning before, you can also have the H2 Square proxy primary to differentiate and send, let's say, requests for domain1.com to the application 1, and those for domain2.com to application 2. So on a more advanced setup, you can start having multiple public IPs with a primary and one or more secondaries that round robin the traffic always or differentiate between two or more application servers. In an even advanced setup, you may have multiple locations. So let's imagine the one on the left is the active location, and the right one is the backup. Let's imagine you have an application that runs on some kind of database you can easily replicate, so you have a cross connection between site A and site B, and you replicate in real time the database. So in case of a failure of your active location, you already have the DNS records published for the secondary, but you're keeping ports 80 and 4043 closed on your backup, so that you just open those in case of a downtime, and you start, and it automatically your service will be online again. So how do we handle certbot validation, which is kind of the whole point? So we usually want to run all the playbooks on the primary HSQL proxy server, so that the certbot validation starts from there. Then the Let's Encrypt server will query their DNS and ask for the A record for the domain we're trying to certify. And you will get an answer like moodle.fus.bz.it in CNAME, front proxy, okay. And then the front proxy has multiple A records. And one of these gets chosen at random. And in the case that it gets chosen a proxy that is not the primary, this will happen. So incoming traffic on port 80 will be handled by the HA proxy front-end HTTP in, which will just check if the path begins with well-known ACME challenge, which is the path certbot needs to access. It will proxy through a private LAN to the primary, to the port 8079 on primary, so that you will answer with the actual server that certbot is running to certify the domain. Otherwise, it will just redirect you to HTTPS. And everything is handled through a single YAML configuration file. You have a big list, which is under the domains variable, and every item of the list represents either a backend of a server to pass the requests to, but also a front-end filter based on the domain name. So in case the domain matches ZBX Squale FusBZ IT, will answer this server at port 4043. And in terms of SSL, we want it to be enabled, and we want HA proxy to verify the certificate of the server we're proxying to. Similarly, we have the same thing on another domain, and here we have just the indication of the server to point to without the SSL part, so we're implicitly telling HA proxy that is fine to proxy on HTTP. So what are the weaknesses of this solution? The runtime, basically, because the sync playbooks across the nodes runs relatively slow also when you're just trying to add a single domain, and we're talking about of 37 seconds of total runtime for 50 domains. I can imagine that if you're handling 500 or more domains, even 1 or 2 minutes of runtime is not a problem for you to synchronize all the proxies, but it's certainly something that can be optimized. And coming to point 2, the tool was written with the Ansible logic of always checking everything. So for every domain that is certified, we read from the Let's Encrypt live directory both the private and public key, and then write it down, or let's say Ansible will check by itself if it's already up to date, and if it's not, write it down. So it has a consistency check under the directory that we are using in order to provide HA proxy with all the SSL certificates for the domains we are working with. There are other ways to do this. For example, you could have playbooks just to add and remove domains, but this would become terrible to handle in terms of renewal and both for troubleshooting. So if you don't check the consistency of everything from the primary itself, it would become difficult to know, let's say, for example, which certificate is expired. All right, that was it. You have you can find the source code of this solution on gitlab.com mrdevhsquare proxy. And if you want to get in touch, just remove no human from my mail, and I'll be happy to talk with you. If there's any question, of course, I'll be happy to answer.
Thank you, Marco Marinello. Are there any questions? We have still some time left. There's a microphone, please.
You can use even for other service like SFTP over HTTP.
Yes, so HA proxy has different levels of working. If you work on the HTTP protocol level, you can use the SSL termination and also check the domain names the client is connecting to. If you want to use lower levels like TCP, which is commonly used, for example, to balance connections to databases, you can do that, but you can use less features in terms of checks and so on. But it's entirely possible. Yes.
Thank you.
I see no hand, so let's thank again Marco
Thank
Marinello, and we see us in 7 minutes for the next speech. Good afternoon and welcome back to the DevOps session of SFSConf. Let's say hello to our speaker, Giorgio Di Tizio from the University of Trento. He's a PhD student there working on the topics of cyber threat intelligence and cybercrime in the DISI security group. Please, for your contribution.
So thank you. So I'm Giorgio Di Tizio, and today I will present our work. Why are you not updating the effectiveness of software updates against advanced persistent threats campaign? So what are advanced persistent threats? Are basically highly organized group composed by professionals that typically perform targeted attacks with the goal of espionage, sabotage, and sometimes financial gains. And we for sure heard of some of these attacks. For example, Stuxnet, there was a attack that target Iranian nuclear plant with several 0 days, so vulnerability the vendor were not aware of. More recently, attacks at the Ukraine power grid or the SolarWinds hacks, in which the APTs basically compromise SolarWinds to then deploy a backdoored version of a software to compromise several government agencies and also companies like Microsoft. However, not all these APT campaigns are all that charming, full of 0 days and advanced techniques. We have a lot of attacks that are not that complicated. So we have, for example, Copy Kittens, that is an Iranian cyber espionage group that basically performs simply phishing emails, and once it's inside the network, exploit common tools like Metasploit. Or the hack on the Jean Podesta Gmail account that basically exploited just, again, a fake email of Gmails saying that the password must be resetted and basically redirect the user to a fake website. So where's the truth? I mean, we typically get influenced by highly spectacular news about incredible attack, and we risk to lose the general picture. So not having a general picture of the APT ecosystem is a problem if you want to evaluate the effectiveness of possible security mitigation. And software updates are obviously the first line of defense that basically can reduce the attack surface on the software. However, for an organization that want to deploy software updates, this is also problematic because some updates can basically change some functionality and so break functionality that are used by the organization. And the problem is even more complicated by the fact that the release of a software updates is often detached from security events that can be, for example, the reservation or disclosure of a software vulnerability. And even more, we have that the exploitation of a software vulnerability is typically detached from the disclosure or the release of an update. So we can have attacks that are able to exploit a software vulnerability before the disclosure, before an update, after a disclosure. So enterprises are left with this complex problem of deciding when to update and how to update. So potentially they could update immediately as soon as a software update is available, but we know that this is not always possible because you have to perform some tests to check that, for example, all the functionality you need are not touched and still works. You can wait some time to do this regression testing and then updates, or even skip the updates if it's not necessary. And what happens is that the first things to update immediately is typically complicated, and enterprise typically wait sometimes or even skip updates. So when they apply the updates, they typically wait some time to perform regression testing. And obviously, this behavior of not updating will be irrational when we think to protect our network against advanced and persistent threats. And to understand if this behavior is really irrational, we need to have a better picture of the APT ecosystem. So what we did, we start collecting information about APT campaigns from open source intelligence, and we created a large database of this campaign, containing more than 350 campaigns in the period between 2008 and 2020, with information about the date of this campaign, the APT groups, the attack vector that employed, the software vulnerability that exploited, and then we enriched this data from other sources like MITRE ATT&CK to get, for example, information about the TTP, so the technique used to exploit, to basically compromise a network, and as well as from NVD to get information about the software vulnerability, so the CVE, the software version affected, and then from potential available updates for each software vulnerability. And from this big database, we start looking at the evolution of these campaigns, and we look at the effectiveness of different software updates for 5 widely used software products that are widely also targeted in the period of interest. And if we look at the results, so having a better picture of the APT ecosystem, we first look at how adversary compromise the network. And the attack vector that they prefer is typically spear phishing. So spear phishing can be, for example, an email that contains a link to a malicious website or a malicious attachment. And this kind of attack can be done with or without the presence of a software vulnerability. And we can see that basically for all the attack vector, all other attack vectors, for example, we get a lot of news, for example, supply chain attacks are actually very rare. So the main problem is simply spear phishing, that is a human problem. And what we also looked at independently from the attack vector, we had in more than 50% of the campaigns that we observed, they did not exploit at all a software vulnerability. So what does it mean? That actually not updating, so not begin with the newest version does not help in at least 50% of the APT campaigns we observed, obviously. When instead software vulnerability exploited, obviously Office is the main target. This is coherent with the fact that we have spear phishing, so typically emails with the malicious Office documents. And then we have that if we group together by vendor, we have some mainly targeted software product like Office, Flash Player, Acrobat Reader, IR, and GRI. And we basically look at this software and how we can update and apply different update strategy to see which is the most effective ones. More in depth in software vulnerabilities, we collected information about 118 software vulnerability exploited by APTs, but the most important thing is again that most of these vulnerabilities are shared between different APTs. So APT tend to reuse this very same vulnerability because they found out that they are still available on the software, and they don't need to innovate and find unique vulnerability to compromise their victim. Just 8 out of 86 exploit vulnerabilities that were not observed in any other group. If we look instead at the choice of the software vulnerability in terms of, for example, known vulnerability versus 0 days, we again find that most of the campaigns exploit known vulnerability, so publicly known vulnerability, while just a minority of them exploit unknown vulnerability. So what does it mean? That potentially software updates can help for those campaigns that exploit software vulnerability. So we look into this more into the detail, and we analyze the different potential update strategies. And we considered 2 cases. One that is the best case scenario, one the worst case scenario. Why we did that? Because we can potentially have in our simulation interleaves between updates and campaign at the very same time. So basically the best case scenario consider the application of the updates before the application of the campaign, while the worst case the vice versa. The first strategy we consider is obviously the optimal strategy that an organization could achieve is basically updating as soon as a new release is available without obviously performing regression testing. And we can see that probability is pretty low, between 10 to 30%, but we know that this is a pretty unrealistic scenario, and it costs a lot in terms of updates. Consider that this is for just 5 products. And we can see that the worst case scenario already, the performance are worse. We have that, what does it mean? Basically, we have that in several cases, the application of the basically release of an updates happen in the very same moment of the exploitation. So basically, attackers are pretty fast in exploiting the vulnerability once the updates is out. If we instead look at the strategy that is much more realistic, so basically a strategy in which we update to each new version, but basically we wait some time to perform regression tests, in this case 1 month, we basically see that obviously probability significantly increase. We still pay all the cost of updating to each new version. So this is basically what currently many organizations are doing, trying to keep the pace of the updates, but trying not to break functionality by doing some regression testing. So what we thought is, why not instead doing something more relaxed, so a reactive strategies in which we just update for, in the case a publicly known vulnerability is released. and again, waiting 1 month, in this case, to perform regression testing. And what happened is that we have the very same risk profile of the industry strategy, so the ones that update to each new release, but we save more than 30% of the updates. So what does it mean? That basically if an enterprise is not updating and is just applying a reactive approach on publicly known vulnerability, has the basically same risk of being compromised by the APTs. So in summary, we built a structurally manually verified database of APT campaigns containing information about software vulnerabilities, attack vector, TTPs, and we use this database to investigate the effectiveness of software updates. What we observe, first of all, that not all APT are as sophisticated as we think and we get from the news. Many employ common technique, basic technique, and prefer publicly known vulnerability. But more importantly, basically, we found out that the effectiveness of an update strategy is reactive on the publicly known vulnerability, has a very same risk profile of always trying to stay on the edge of the new updates, but the first strategy, so the reactive one, saves you from a lot of updates. And if you want to get more details, we have a paper on that, and our APT dataset is obviously open. So that's it. Thank you.
Thank you, Giorgio and Tizio. Are there any questions to our speaker?
Thank you. Could you explain maybe again the key takeaway from the two strategy difference? I didn't get it quite.
Yes. Can I go back? Thank you. Okay, basically, between industry and reactive, right?
Right.
So basically, the industry wants is an attempt to stay on the edge of each new updates.
With a month
yes,
for
exactly. Basically,
okay.
it arises a new updates. I obviously need to test it, and then I will apply. Then arise another update for that. Independent of what it's doing, I again do regression testing and apply the update. So I try to think, okay, if it's an update, is much more secure, independently of what it's doing, okay? And obviously, this is costly in the term that you have to apply each single update. While if you just say, okay, I just consider this update if it's patching something, then basically I have the very same risk profile of being compromised, so the probability stay the same of being compromised by a campaign, but obviously I ignore many more updates. The idea of the first strategy is saying that, yeah, it's newest, this update, this version, so it's potentially much secure, because it's potentially patched something that sometimes they didn't even know to you. So it's happened that, for example, we have updates that do not really say they patching vulnerabilities before some time. So it can happen, for example, also with the WhatsApp. It happened for a vulnerability exploited by an SO. It basically was patched with an additional feature added to WhatsApp, while we were instead actually patching a software vulnerability. And then eventually they released basically the fact that it was also a software vulnerability. There was also a software vulnerability. So that's basically the difference.
Okay, thank you.
You're welcome.
There's still time for a short question.
Hi. So I saw in the list of software you researched about, it was mainly focused on proprietary software and on open source, let's say, and free software instead. How do you think the question develops? So according to my memory, which may not be that good, but for example, Microsoft Office, if I recall correctly, should have in a lifetime span 1/10 of known CVEs against the competitor Microsoft Office. So is updating on open source easier and more secure?
That's interesting. Okay, apart from this, there are also some open source ones, so typically affecting the Linux kernel, for example. This is more for persistent. I don't think so. I actually think that sometimes it's even easier if we consider the scenario between ideal best case and ideal worst case, in which we have a lot of overlaps between the release of an updates and the exploitation. This is typically done by doing reverse engineering. Reverse engineering on closed source. So for open source can be sometimes even easier because you have basically actually the code, the change in the code, basically the real code, not actually the reversed one. So sometimes could actually be much easier. But obviously this depends also on the interest of the attacker. So if this is actually used, these are targeted attacks. So if the victim is using this kind of source, open source software, then they will eventually exploit it for sure.
Thank you, Giorgio Letizio, for the further discussion. So I ask you to postpone it in the breaks, and we see in 3 minutes back here in this room for our last presentation. Manage your own domain name server. See you soon. Do not flee. So, good afternoon to the DevOps track of SFSConf. Welcome to our last contribution, and welcome to our speaker, Dashmir Hoxha. Dashmir Hoxha is a computer engineer with 20 years of experience in different fields. He loves to do automate with scripts and share his knowledge. And since a few years, he's participating at SFSCon. So we are curious to hear his presentation about how to manage your own domain name server. Please.
Hi. So in this presentation, I'm going to talk about how to manage your own DNS. When you purchase a domain from a service provider, it also gives you the opportunity to manage your DNS records. So you have a web interface, and then you can enter DNS records in this web interface. So basically, you are using the name servers of the service provider in this case. But it is also possible to use your own DNS server to manage the DNS records of your own domain or domains if you manage several domains. And actually, this is not quite difficult. It is not difficult. It is easy. And I'm going to show in this presentation how I do it. And you can also do it in a way that is slightly different. The basic concepts and ideas are the same. So first of all, let's see how DNS works. Maybe you know, but it doesn't hurt to remind it. So if a client wants to find the IP, for example, for the domain cloud.example.org, then, and let's say that he doesn't know anything, he doesn't have anything in cache, so he has to find it out from scratch. Then, first of all, he has to contact the root name servers and ask it which servers are responsible for managing the top-level domain .org. Now, how does this client know what are the root name servers? Because he has to know the IP of the names. Actually, there is a list of root name servers that is built in. They are fixed IPs, almost fixed. They don't change over time. And the client can can send the request to any of these fixed IPs. And now we have a list of name servers for the domain.org. And we can ask any of these name servers. For example, let's say that there are 5 or 6 name servers. We can ask any of them for the name servers of the subdomain example.org. All these name servers are synchronized with each other. They have the same information, so it doesn't matter which one we ask. And even the list is in a random order. Having several name servers for a domain helps both for high availability, so that if one name server is down, then you can ask the next one, and you will get the answer, and also for load balancing, so that not all the requests go to one server, but they are distributed among all of them. So now that we have a list of the name servers for the domain example.org. For example, this list is ns1.example.org, ns2.example.org, ns3.example.org. We can ask any of these name servers, what is the IP for the name cloud.example.org? So we can try these steps by using the command dig. The command dig is used to ask information about DNS records. So if we use the command dig ns dot, we get a list of all the name servers. But if we add also the option short, then we will just get the list without extra information. And the result will be something like this, like m.rootservers.net, b.rootservers.net, etc. So it is in a random order. We can pick any one of them, for example, the first one, and then send a request to it, dig ns al at m.rootservers.net, or with the option short, and then we will get a list of the name servers for the root domain al.al, which is for Albania. And we can ask, for example, the second one, nsx.nic.al. So dig nsfs.al at this name server, and then we will get a list of the name servers for the domain fs.al. And finally, we can ask any of these servers for the IP of the domain ocw.fs.al. So we said that the list of name servers for a specific domain is synchronized with each other. How is this synchronization accomplished? We can use one of the name servers as primary, and all the others copy the records from this name server. But we can do something better. We can put the primary name server in the background, behind a firewall, so that no client or nobody can contact it except the secondary name servers. So we make the changes of the records only on the primary name server, and then it is synchronized with all the secondary name servers. And the clients actually query or ask only secondary name servers. And secondary name servers, actually what is done is this. Whenever there is some change in the records of the primary name server, it sends a notification to secondary name servers that there are some new content. Then when a secondary name server gets this request, it sends a query to the primary name server, give me a list of all the records. The primary name server sends this list back to the secondary name server, and then secondary name server replaces the old list with the new one. So effectively, it updates its list. Now, from this diagram, we see that we need to build a primary name server and some secondary name servers. But actually, there are some services that offer secondary name servers for free or for a small price. And some of them are listed here. For example, buddyns.com, 1984 hosting.com, etc. So these are the ones that I actually use for my domain. If you look around, you can find some other ones with a small price or for free. And as a terminology, the primary, secondary name servers are also called master and slave in the old terminology. But if you go to these websites, you can find master and slave, not primary and secondary. So we don't have to build secondary name servers because we can use these free services that can serve as secondary name servers for us. We need to build only the primary name server. And for building a primary name server, we use DNS software like Bind9 or NSD, or there are some other software as well. I'm using NSD, and I install it in a container. And this primary name server is not resource intensive. It is 99.99% idle. It doesn't do anything. Only when there are some changes, it communicates with secondary name servers. So it is a loss of resources to use VPS for the secondary name server. Instead, I install it in a Docker container and put this Docker container in some VPS that also does is hosting some other services. And to install this NSD container, I'm using Docker and Docker scripts. You know Docker. Docker scripts are some bash scripts that I have developed for managing Docker containers. And here are the steps. I cannot explain anything here. It is better if this was a workshop where I can type and show the result. And the NSD container is using the port 53. This is the DNS port. But usually in Debian and Ubuntu, RS and Debian and Ubuntu systems, port 53 is used by another service, which is systemd resolved. So we have to find out how to disable this service and then leave the port 53 unused, so that it can be used by the DNS container. And here are the steps how to do this. And here I show the list. There is the list of secondary name servers that I'm using. For example, ns0.1994.is, etc. And AXFR servers are the IPs that are used by these secondary name servers to send AXFR queries. And I need to know these IPs because I open these ports in the firewall, and I tell in the configuration of NSD to allow the ASFR requests coming from these IPs, and ignore all other requests from any other IPs. And now we have installed the main server, but there is no domain yet that we are managing. So how do we manage domains? Suppose that we have purchased the domain example.org. So when we purchase the domain, the service provider gives you also the possibility to enter some NS records. NS records are telling it that the records for this domain are managed by these servers. So if we add 3 NS records, then the DNS records for this domain are managed by these servers. So we are adding these records in the configuration of the service provider from which we are purchasing this domain. In this case, I am adding these three services, these name servers. These are the secondary name servers. And then we go to the website of these secondary name servers, and we have to tell them what is the IP of the primary name server. We register the domain that we want to manage, and then tell it what is the IP of the primary name server. And we also add a domain at the NSD, at the primary container. And when we modify DNS records, we edit this file, for example, zones example.org.db. Then we should not forget to change the serial number, and then we type this command ds notify so that it sends notifications to the secondary name servers. Actually, the time is short to explain all the other steps. It will be better if this was a workshop, and actually next week on Friday evening, I'm planning to organize a workshop. If you want to participate, you can use this URL, that is the third one, the last one, events.fs.al to register, or you can read it from this barcode. So thanks for your attention. If you have any questions, you can.
Thank you, Mr. Hoxha, for sharing your expertise. Are there any questions? It's already late in the afternoon. Thank you for your offer, for the course, and for your presentation. And so thank you for your participation, and I wish you a nice continuing of SFSConf and a nice hackathon for who participates all night long. So thank you, and see you next time at SFSConf.